Hi everyone and welcome back to my channel. So I am back with another marathon. So this time we'll do the complete marathon of step and impulse response for all first order RL circuits for current excitation. So previously I had completed voltage excitation. I had done for like voltage excitation for RL, voltage excitation for RC, and like pulse response of RC and RL, right? All those are covered. Okay, RL1 is currently private because you guys didn't complete the light tag. Okay, so if you want the RL marathon with voltage excitation back, you can comment down below and obviously like this video. Simple thing is that few paid course students were asking that they want more content on RL circuits. They want this current excitation, so they were asking me to do the marathon. But I told them that maybe it's not possible because I am too busy right now. Like lot of things are going on side by side. So I told them not possible. Then I thought like, if they're wanting it, maybe I can arrange something. Okay, so then I put up a poll on my YouTube community post, and there like around 100 students, they voted that they want a marathon, and they want like 70% of those told that they want an RL. So this was just 2 days back, so I had to like wake up, be awake all all night and prepare the content and all those things, right? So like this took me a lot of hard work. So this is the only thing that I will expect. Please do like the video, because trust me, this took me a lot of hard work to keep get this ready within 2 days, right? So I have my work as well, right? So I had to wake up, sleep very less and just prepare the content and somehow put it before Independence Day, because it's a big day and we want something big to happen. That's why we were I was also trying to put it before the Independence Day or on the Independence Day. So what I will expect is, please like the video, please. It took me a lot of effort, so this much I can expect from you, right? And if possible, I will put the link of my LinkedIn post on the comments below. Please repost it. I will put I will post the notes, so you can follow me on LinkedIn if you want regular notes and all those things. All those things I provide on my LinkedIn, so you can repost the notes of my post that I will post in my LinkedIn profile, right? So please do repost that, so that will motivate me to make more videos like this, because trust me, this video drained me a lot because I had to work really hard for this. Okay, then I will expect at least share this video, and if you repost, that's also enough. If you repost the LinkedIn post, that is also sharing. So please do it. And obviously I want you to study focused, be fully attentive, and trust me, you will learn a very good concept of inductors in the middle part. Okay, in the main portion I will tell you which question has the best concept. I will tell you that. Okay, and also very important announcement is that we are running off on all our courses. So offer is currently running, of special offer, that is of Independence Day. So you can get all our courses at 78% of the full price. After this, the prices will be price will rise after this. So I don't know whether you will get all the courses at this low price after this, right? I don't know. You will be able to get all the courses at this low price. So you can use the coupon code India78 and you can get a total discount of 22%. That is, you can avail all the courses at 78% of the full course. That this type of discount you won't get on the special celebration of 78 Independence Day of India, right? So this was a big announcement. You can visit our website prefusion.in. There you can visit. Okay, there you can purchase your course. Where we have currently launched engineering mathematics course. We have launched analog VLSI for placements, analog for gate course. Then we have launched many test series, network theory test series, then analog electronics test series, aptitude test series, engineering mathematics test series will also come, control will also come. Those are on the works, so those things will come, right? You can keep an eye on that. So these are few offerings that we have offered, and don't worry, we are there for the free students as well. In our website, completely network theory is completely for free, control system is completely for free. Okay, in our website, and you can follow our other channel, that is Prefusion. There also we post multiple stuff free there, right? So analog electronics, I think first chapter is also there for free. Engineering mathematics, the 2 chapters are there for free, right? Calculus and linear algebra, so you can watch that. So we do care about our students as well who can't afford, so we do that as well. Okay, so those were few important announcements. Also, you can follow this playlist. This is the place where all the marathons are available. Then also you can follow this playlist, that is circuit queries, why I solve questions which can be asked in written exams, right? And then you can follow this playlist, analog electronics decoded, where I mainly solve interview related problems. Okay, so these 3 playlists are there, you can follow it for further enhancement. Okay, and obviously you can follow our channel Prefusion, there also we post many content regarding gate and placement and other things. Okay, so this was the important announcement. So what are the questions here? So questions are, you have to evaluate and sketch the output voltage and output current for a unit step and unit impulse voltage, not voltage this time, this is the current, right? So we have changed to current excitation. So unit impulse and unit step current, assume that inductors are unenergized initially, so they have no flux initially. Okay, so what are the circuits? These are circuits, right? So these circuits are standard circuits, these are pretty simple. This has very good concept, so you must watch this. Like if you are not watching anything, you must watch this, right? This has the best concept, and again this question is also the best one. Okay, this question is best one, and after this there are few tricks involved, so you have to know whether you know the like whether you are able to apply the tricks or not. So this circuit, then this circuit, this. So what I will recommend is you pause the video and then you try to attempt it by yourself, right? So these are the last two. This look intimidating, but actually how intimidating are they? So that we will understand while we'll solve this. So these were all the questions, these are all the circuits. Now we'll start with the solutions. Thank you, and I hope you enjoy the video. So let's start with the solutions. So we have this first circuit, so we'll solve this first circuit sequentially. First we'll do the unit step response, then we'll do the unit impulse response. Okay, so first of all, we have to identify how many number of independent energy storing element is, what is the order of the circuit, then only we can say whether the response of the circuit will be exponential in nature or it will be some other type of waveform. So here, right, if I see only I have one energy storing element, so this is very simple. As I have only one energy storing element, that means the order of the circuit will also be only 1. Okay, so hence the pole, like number of poles will be 1, it will be a single pole, and as the number of pole will be 1, if I do the Laplace inverse, it will be a exponential response, right? Exponential response if I take the Laplace inverse of this. Okay, so what will be the time constant of the circuits? If it is a first order, then there must be a time constant, right? And the time constant is simply L equivalent upon R equivalent. So in this case I have only one L and one R, so it will be L by R. So the first circuit is simpler, but you try to analyze like this only, then only you will be able to solve the complex circuits. Okay, so let's now start with the initial and final conditions. So here initially what is happening? Initially the inductor doesn't have any flux with it, so initially inductor has zero flux. Initially inductor has zero flux, that is psi of 0 minus is equals to 0, that is Li of 0 minus. Li of 0 minus is 0, right? As I like it has no flux, hence I of 0 minus is equal to 0. Now is it equals to I of 0 plus? Because it will want to keep that same current, right? So at t equals to 0, what is happening? T equal to 0, here I have a unit step. Okay, and at t equals to 0, if I just draw the circuit at t equals to 0, this will be open circuit because it won't pass any current. So all of the current will pass through this. That is fine, right? At t equals to 0 plus, all of the current will try to pass through this. So this unit step will be converted into a 1 amp, and this resistor will provide the path for this current source to flow. So it's fine, all the circuit conditions are satisfying, hence this I0 minus will be equals to I0 plus, hence there won't be any impulse voltage that will appear across the inductor. Hence my VO of 0 plus will be what? VO of 0 plus, or I can say VL of 0 plus. It will be what? It will be simply R, right? Simply R, because 1 ampere current is flowing. So which is, first of all, obviously it is finite, hence like the inductor won't change its current instantaneously, it will still remain 0, and it is positive. Now as it is positive, right, if it is positive, what does it mean? That means what is the equation of inductor? Voltage equation, it is L dIL by dt. Now as this VL is positive, that means L is constant, so dIL by dt will be positive. dIL by dt means the rate of change of current is increasing, right? dIL by dt means what is the rate of change of current? Rate of change of current is the rate of change of current is positive, that means current is increasing, it is increasing. So IL will increase. Okay, because drop is like this. So I will increase and to what value to increase? At steady state, what will happen? At steady state, the rate of change of current will be 0 across the inductor. At steady state, at at t equals to infinity, right? Steady state, what will happen? DIL by dt will be 0 because rate of change of current will be 0. As this is 0, right? That means my VL will be 0 because VL is equals to DIL by dt. So if I draw the circuit at steady state, what will happen? At t equals to infinity, at steady state, this will be simply short circuit. Okay, not this, simply short circuit. So if this is short circuit, right? What will happen? The drop will be 0. So drop across this whole resistor will also be 0. As 0 drop across this resistor, hence 0 current will flow. Hence all the current will flow through this. That is whole 1 ampere of current will flow through this. So my IL of infinity will be 1 amperes. And this is equals to my IO of infinity as well. And as the response is exponential, it will go from 0 to infinity like this. And my VO of infinity is obviously equals to VL of infinity, which is equals to 0 volts. Okay, so this will be the total flow. So the how will the response look like? So IL, or I can write here as IO, right? IO of t, it will be simply exponential. It will go from 0 to 1 amperes. Just hold on, yeah, like this. It will go from 0 to 1 amperes, right? Exponentially. So this value, steady state value, will be 1 amperes, and this will start to go from 0 to 1. And in what time? In 4 tau. Tau I have already defined. Tau is L by R. And what will be the voltage? Voltage instantly at t equals to 0, it will be what? R. Then at t equals to infinity, it will go to 0. It will be some positive value, that is R, and t equals to infinity, it will go to 0. And this will be some 4 tau time around which it will almost be equals to 0. What are the equations of voltages and current? So IO of t will be simply 1 minus e raised to power minus t upon tau EO of t, and your VO of t will be simply R e raised to power minus t upon tau. Okay, so this was about the step response. Now for impulse, we need to be a little bit careful. So for impulse response, what will happen initially? Like I will obviously say the intuition first. Initially, what will happen is that at t equals to 0, this is open circuit. Okay, if this is open circuit, then what will happen? All the impulse current will flow through here, and if impulse current is flowing, what is the drop across this? It is R delta t. So impulse voltage is instantaneously getting applied across this inductor. So this inductor will also be charged with some finite current, because the initial and finite current won't be same. As initially it has no flux, but as a impulse voltage is getting appeared across this inductor, the inductor will get instantly energized to a certain amount of flux, and due to that flux, it will flow some constant current just after that. And then what will happen? That constant current, this will be open circuit, because this impulse will be just present at t equals 0. At t equals 0 plus, this will be open circuit, no current will flow. Hence this, whatever this energy has been transformed into this inductor, that will discharge through this resistor, and in the steady state everything will become 0 again. Okay, this is the induction. So let's now actually analyze the circuit. So I will again do the same thing. Inductor initially has no charge. So this thing remains same. But what about this voltage drop, right? What about this voltage drop? I will just copy and paste over here. Inductor initially has no charge. Now, is this true? Is this thing true? So for this, we need to draw the circuit. If I draw the circuit at t equals to 0, exactly at t equals to 0. If I draw the circuit exactly at t equals to 0, so there is an impulse. Okay, and this is at t equals to 0. So at t equals to 0, this inductor will say, no, I don't want any current to flow because I resist change in current. So inductor resists change in current, so it will not allow any current to flow. But what will happen is, the whole current will flow through this. So this will create a drop of what? R delta t. Now what is the VO of 0 plus? VO of 0 plus is simply R delta of t and is it finite? It is not finite, it is infinite. Infinite. So as it is infinite, what will happen? As it is infinite, inductor will change its current instantaneously. Why is it so? Because if I write down the equation, right, VL of t is equals to VL of t equals to L DIL of t divided by dt. So basically, just keep it here. Write it that VL of t is what? At t equals to 0, VL of t is R delta of t, and this is L DIL by dt. Now if I integrate it just from 0 minus to 0 plus, if I integrate it just from 0 minus to 0 plus, what will happen is that this will be R by L, and integration from 0 minus to 0 plus of delta of t is simply 1, and this will be I of 0 plus minus I of 0 minus. Now as I of 0 minus is 0, this will be simply 0, so hence my I of 0 plus will become simply R by L, right? So it will be R by L, and obviously there is a U of t also across this. Okay, so I of 0 plus will be R by L, right? I of 0 plus will be R by L. So if I draw the circuit now, if I draw the circuit at t equals to 0 plus, at t equals to 0 plus, how the circuit would look? At t equals to 0 plus, the impulse will be gone, right? Because impulse is present only for t equals to 0. Okay, the impulse will be gone. So this current source will give 0 current. If current is 0, that means it is open circuit. So it is open circuit, and now the inductor has been charged to some like inductor has been energized to some current, that is R by L. R by L. Okay, so this amount of current is flowing through this inductor. Now what will happen is that, what is the drop across this? Just hold on. What is the drop across this resistor? This is at t equals to 0 plus. What is the drop across this resistor? If I observe this carefully, current is flowing like this. Okay, if current is flowing like this, drop will be somewhat like this, that is this will be R square by L. R square by L. Okay, this will be R square by L. Now the drop is R square by L, right, across the resistor. If I observe this carefully, the inductor potential I have assumed like this polarity, right, and it is negative. It is negative. As it is negative, as my VL is negative, that means what? My DIL by dt is less than 0. That means what? Current will reduce now, and obviously that is intuitive as well, because it will discharge to the resistor, because resistor is a dissipating element. It will discharge to the resistor, but mathematically this is what is happening. So here current will reduce, so current will reduce. It will reduce to what? 0, totally discharge at steady state, right? So at steady state, how the circuit will look like? So if I draw the circuit at steady state, what will happen is, this is not present obviously, and this inductor will become short circuited, because at steady state there will be no change of current, and the voltage will be 0. As the voltage is 0, so this drop is also 0. So whole current is, this current is 0, and whatever the current through the resistor, the same current will flow through the inductor. Hence all the current will be 0. So my IL of 0 plus I know. Okay, and what is my VL of 0 plus? Exactly, that is equals to my VO of 0 plus. Okay, so VL of 0 plus equals to VO of 0 plus is what? Equals to minus R square by L. Okay, it should be equals to minus R square by L. So this is my negative. This is coming negative. That means the inductor is de-energized, right? So now what is at infinity? What is happening at infinity? I found out the current at t equals 0 plus. What is happening at infinity? Infinity, right? V of infinity should be 0, and IO of infinity should also be 0, because no current is flowing. So okay, I just have taken extra page. So how will the plots look? So the plots, right, for the current, what is happening? Initially inductor has 0 current, then suddenly the current instantly change to R by L. The current instantly change to R by L. So current will instantly go to R by L. Okay, then what will happen? It will discharge through the resistor exponentially. It is a first order circuit, hence it will discharge to the resistor exponentially, and it will go to 0. Go to 0 within what time? Almost 4 tau. Almost 4 tau. Okay, and what about the voltage? So initially the inductor is line inductor voltage is same as output voltage. So inductor is appearing across a impulse voltage. What is the magnitude of that? That is the area of the impulse is R. Okay, area of the impulse is R. So a impulse voltage will initially get applied across this inductor. Okay, if I just can make this at this left hand side, yeah, impulse voltage will appear, that is R, area is R, right? Area is R. Then at t equals 0 plus, what is happening? Negative voltage. I'm getting a negative voltage, that is minus R square by L. So I will get a negative voltage, and then again the voltage will also reduce. Okay, voltage will also go to 0 at steady state. So why is it negative? Because it is de-energizing. That's why the voltage is always negative. And why is it positive at t equals 0? Because it is energizing from the current source. That's why it is positive. Okay, so let me write down the equations. So what will be the equations? Equations for this will be IU of t so minus t upon tau, and V of t equals to R delta of t minus R by L e raised to power minus t upon tau. Okay, so this will be the voltage and the current equation simply, and there will be obviously a U of t applied with it. So this will be U of t. To be more precise, this will also be a U of t. So this will be the step and impulse response of this circuit. Now let's compute the draw the Bode plot. First, to find the Bode plot, first we have to find out the poles and zeros of the circuit. So what are the poles of the circuit? So poles is very simple, right? Poles is basically the negative inverse of time constant. For a first order circuit, it is the negative inverse of time constant. So SP will be negative inverse of magnitude of time constant. It is minus 1 by time constant is what? L by R. So SP will be minus R by L. Okay, or what you can do, you can make infinite impedance seen from this side. Okay, so if you make infinite impedance seen from this outside, then you will be able to find out pole. Or what you can do is, if you see infinite impedance seen here, right? Why? Because what does pole mean? Pole means the frequency at which my value of the transfer function goes to 0. And do remember this time the transfer function, right, is not unitless. It has some unit. What is the unit? Input is current and output is voltage. The unit will be ohms. So if I somehow make this input, right, seen the value seen from the current source infinite, right, then this current source has to flow. And if this current source flows, then some finite value of current into infinite impedance will make it infinite. Okay, so how can I make this infinite? How can two impedances in parallel be infinity? So this I have explained in my video realizing poles and zeros intuitively. You can go and check out my playlist, that is analog electronics decoded. There I have explained how can you determine poles if and poles and zero intuitively. So here, right, what you have to do is, how do you make infinite impedance? You just make it negative. So this, if this R equals to minus of SL, this will make it infinite impedance. So SP from here as well you can find out minus R by L. Okay, two methods are there. This is method 1, negative impedance, negative of time constant. This is method 2, that is making infinite impedance, right? Making infinite impedance. So yeah, these two methods are there. Now how do you compute the zero? Now zero, right, you have to find out the zero. When does the zero occur in this type of transformation? The zero will occur only when this resistance will go, or when this impedance will go to 0, or this impedance will go to 0. Then this current into whatever this value, this drop will be simply 0, right? So can this go to 0? Can this go to 0? No, R can never go to 0. R is a fixed value, so R is not equal to 0. Can this go to 0? Yes, this can go to 0. At S equals to 0, this can go to 0. If this goes to 0, right, so all of the current will flow through this, none of the current will flow through this. Then what will happen? The drop across this will be simply 0. I into 0 is 0. So I have a 0 at S equals to 0. Okay, so I have a 0 at S equals to 0. I have a pole at S equals to minus r by l, can I have more zeros? I cannot have more zeros, because this is a practical circuit, and for a realizable circuit, the number of zeros and the number of poles can be equal. Okay, sorry, number of zeros can be at most equal, but it can never be more than number of poles, else the circuit will become unstable. Okay, and that is not possible. So what is a DC gain? Again, the DC gain is simple for this, because at s equals to 0, we have to draw the circuit. At s equal to 0, this is getting shorted, so DC gain is simply 0. Okay, DC gain is simply 0. So what we used to do with the help of DC gain, we used to find the A, right? So you will say, sir, A will be equals to 0. No, right? You will not say A will be equals to 0. You have to find out some other way to find out the value of A. This time A will be different for us. Like, I don't know what will be A, but I will find the value of A with the help of the high frequency gain. So at high frequency, what is happening? At high frequency, this will provide infinite impedance. Hence, all the current will flow through the current source only. Sorry, all the current will flow through this resistor only. So what will be the VO at infinite impedance? So high frequency means S equals to infinity. And why is this relevant? I will just explain in a bit. Okay, so here, right, if I just write down my transfer function, whatever I have computed till now, h of s, this time h of s has a unit, that is ohms. So if I write down my transfer function, it is A times, I have a 0 at s equals to 0, A times s divided by, I have a pole at s equals to r by l, minus r by l, right? So s plus r by l. Okay, or if I write this in the time constant format, this will be s tau, right? S l by r plus 1. Okay, so this A is divided by S tau plus 1. Now, how do I find out this A? You will say A is 0. No, A is not 0. DC gain is 0, but A is not 0. What is the value of A now? So I have to find out the A with the help of high frequency gain. So if this goes to infinity and if this goes to infinity, then what will happen? Only the coefficients of this S terms will remain. Hence, it will be equals to, this H of infinity will be equals to A by L by R. H of infinity is equals to A by L by R. And what is H of infinity? H of infinity is VO by II, right? And basically, what is this VO? VO is equals to at infinity, all the current will flow through this, that will be equals to II times R. Okay, so it will be only R. So what will be my A from this? A will be simply equals to L. Okay, A will be, if this is going there, yeah, A will be simply equals to L. So what will be my transfer function? So H of S, right? H of S will be simply L SL divided by SL by R plus 1. Now let's do a quick sanity check, right? Let's do a quick sanity check. This transfer function, right? This transfer function should have a unit. What unit should it have? It should have unit of impedance. So this is what? This is frequency, and this is L by R is tau, that is seconds. So frequency into seconds, that is unitless. This one is unitless. This SL is unit of like the inductive reactance provided by the inductance, right? So this is ohms. So overall the unit is ohms. So whatever we have solved is correct. So this like this you can cross verify if you have solved it correctly or not. Let's do the border plot of this. So if I do the border plot, right? So what is my transfer function? Transfer function is SL divided by SL by R plus 1. Okay, so here, right, what will happen is at s equals to 0, obviously I'm getting 0 again, so it will start from negative, and I have a 0 at s equals to 0, so it will start from increasing. It will start to increase. Okay, it will increase until here, okay, some value. Then at s equals to L by R, s equals to L by R, this is okay, this will not increase until here, this will increase here. We'll explain just in a bit why. S equals to minus R by L, I will get a pole. So this is a pole at R by L. Okay, because omega p is positive, omega p will be R by L only. And after this, right, after R by L, this is like this 0, this slope is plus 20 dB per decade plus 20 dB per decade provided by the what? Provided by the this 0, right? S equals to 0. Now at this R by L I encountered a pole, hence this will give me a slope of minus 20 dB per decade. So overall slope will become 0. Hence this will be 0 only. This will be 0 only. This will be constant. Now at infinity, what is the value? The value is simply L, right? Gain is at infinity. Gain is what? T equals to infinity. Gain is R. against R. So all of it will depend upon R. So if R is greater than 1, so this axis will lie above the 0 dB axis. So I will assume that R is greater than 1. So in all the questions, right, all the questions I will assume that R is greater than 1, because anyways, okay, depends on the value of R. If R is less than 1, this will be negative, because at t equals to infinity, my value is this. My value is 20 log R. Okay, so t equals to infinity, my value is 20 log R, and that at that point it will settle. Only at that value it will settle. Okay. Okay, this is not the point actually. This is the point. This is the point R by L. Okay. So this will be the Bode gain plot basically. Now let's do the Bode phase plot. Okay, if I do the Bode phase plot, what will happen? If I copy this transfer function and draw the Bode phase plot. Now for phase plot, right, you have to identify the location of zeros and poles. So here at s equal to 0, I have a 0. So instantly it will provide me plus 90 degrees of angle. So instantly I will get a plus 90 degrees of angle. Then you have to be a bit careful, because why is the next pole? Next pole is at, let's say, omega p, right? Omega p is R by. So I will write omega p as R by L. Now at 10 times before omega p and 10 times after omega p, the effect of this pole will start to happen. So what will happen? From, let's assume here at omega p by 10, the effect of pole comes into the picture. Then this is omega p and this is 10 omega p. So all this I have explained how to draw Bode plots and all these 6 things in my playlist. You can go through there and understand how do we draw the Bode plots. So this will reduce, and up until the 10 omega p, the effect will be present. Then it will be totally gone. And where will it stop? Like at 10 omega p, what will be the value? The value will be simply 0, right? Because this is providing overall, the 0 is providing overall 90 degree phase shift, and overall this pole is providing minus 90 degree phase shift. So overall phase shift will be 0 at the end, at s equals to infinity, right? So this will be 90 degrees and this will be 0 degrees simply, and this will be the case. And before omega p by 10, the slope will be simply 0 degree per decade. Here the slope will be minus 45 degree per decade due to the pole, and again the effect of the pole will go away. So again the slope will be 0 degree per decade. So this will be the Bode phase and Bode gain plot. Now let's solve the second question. So let's solve this second question. So this second question is almost similar like the previous one, just differences. We are measuring the voltage across the R, and like voltage waveform will be same, just the current waveform will be different, right? Because we are measuring the current across the R. Everything else remains the same. So number of passive elements will be same only, because like we have only one energy storing element, so it will be only one. The time constant will be like, it will be exponential, as there is only one energy storing element. It will be exponential, and the time constant will be simply L by R again. Okay, it will simply be L by R. Then what about the initial and final condition? So again, initially flux is 0, as initial flux linkage is 0. Then my initial I current, right, initial current across the inductor will also be 0. So will this be same? Obviously this will be same for the unit step response. So it will be, again, you can understand, it will be same as the previous case, that initially a 1 amp current will try to flow through this whole circuit, and inductor will not allow any sudden change of current. So whole current will flow through this R, and drop of R will appear across this inductor, which is positive. Hence the current will increase, as voltage is positive, and current increases to what? It will increase to totally this I current, right? I of infinity. So that is what it will increase to. Then to 1 ampere current, as it is a unit step. Then what will happen is that the voltage drop will be 0, hence no current will flow through here, and that will be the steady state. That will be the unit step response basically. It will go like exponentially, go up like exponentially. So here like you can draw the circuit for t equals to 0 plus. So if I draw the circuit for t equals to 0 plus, what will happen? This will be open circuit. Now as this is open circuit, all of the current will flow through this. So this will be a 1 ampere. This will be replaced with a 1 ampere of current source. 1 ampere of current source. Okay, so whole 1 ampere of current source will flow through here. Okay, so now what will happen? This is R, right? So this is a circuit at t equals to 0 plus. This is circuit at t equals 0 plus. So now what will be my VL of 0 plus equals to VO of 0 plus, which is equals to simply R, right? Whole of the current is flowing to that, which is R, which is positive, and it is finite. So current will obviously not change. Hence my IL of 0 minus should be equals to IL of 0 plus. Okay, IL of 0 minus should be equals to IL of 0 plus. So which is equals to 0 amperes. Now at steady state, what will happen if I draw the circuit at steady state? Okay, this is not the circuit, this is the circuit, right? The inductor will get obviously short circuited, and if it gets short circuited, then what will happen is all of the current will flow through this inductor, because the drop across the resistor will be simply 0 volts. Hence all of this 1 ampere of current will flow through this. Okay, this is at t equals to infinity. So my IU of infinity will be what? 0, because now we are measuring the current across the resistor, not across the inductor. My VO of infinity will be simply 0. Okay, so the unit step is pretty simple. So initial, this is not IL, actually this is IU, right? This is IU, this is IU and VO. So initial current was totally 1 ampere, then it decayed to totally 0, and like obviously voltage will follow current, because I'm measuring the voltage across the resistor. So voltage and current will be proportional to each other. So this will be 1 amperes of current initially, and this will be voltage of R, right? Initial voltage, and this will decay down to 4 tau, and this will also decay down to 4 tau. Just hold on a second, let me check if everything is fine and recording. Yeah, everything is fine and recording. So now what are the equations? So equation for IO of t will be simply e raised to power minus t upon tau into u of t, and equation of VO of t will be simply e raised to power minus t upon tau u of t. Okay, now what about the impulse response? So impulse response, what is happening when impulse is produced? So whole current will not flow through this, whole impulse current will flow through this, which will develop a impulsive voltage, infinite voltage. So the voltage across the inductor will be infinity. Hence due to this impulsive voltage, the inductor will get instantly energized to some value, that is again R in this case. R in this case, and the flux will be R, and the current will be R by L. So inductor will then discharge through this resistor R by L, because this path will be open, because impulse is only present at t equals to 0. Then whole of the current will get discharged through this R, and at the steady state this will be 0 only. Okay, so that is basically how the induction will look like. So this thing will be same, only the inductor initially has no charge. But what about the VL of 0 plus? So VL of 0 plus, right? VL of 0 plus is this time is not finite, because if I draw the circuit at t equals to 0, exactly at t equals to 0, this will be replaced with a impulse. Delta of t. So this will be open circuit. So a whole impulse current will flow through this, that is delta of t. And what will be the drop? Drop will be R delta of t, right? R delta of t. Okay, so basically the inductor voltage is this time R delta of t. So this is actually a VO R delta of t, which is not obviously finite. It is infinite. As it is infinite, right? What will happen? This will not be equal. This will not be equal, and this will not be equal to 0 ampere. So inductor will get instantly energized. What value it will get energized to? So VL of 0, VL of exactly 0 is this value, right? VL of 0 is R delta of t. So obviously my IL of 0 will be what? Again integration. IL of 0 plus will be simply integration of VL of 0, so 1 by L, and if I integrate it an impulse and divide it by 1 by L, it will be R by L ampere. So this will have R by L at t equals to 0. So if I, okay, this second hasn't been copied yet, right? So then what will happen is this inductor will again discharge. The same thing will happen. So I will just go a bit fast here because I've already explained everything. So this impulse will current will go away. This inductor will have a current of what? So this got like, this is the positive potential, right? So this got energized somewhat like this. So the current direction will be somewhat like this. Okay. So this will be, current direction will be this. Okay. And this is the R by L of current. So whole current will flow through this, and what will happen? And negative impulse will, negative potential will appear across this inductor, that is R square by L. So this time my VL is minus R square by L, which is less than 0. Hence my IL will obviously reduce, right? As IL reduces, overall current will reduce, and at steady state what will happen is, at steady state everything will go to 0, and this will become simply short circuit. Okay, so hence the drop will also be 0 across the resistor, hence the current will also be okay 0. So my this is equals to my VO of 0 plus, right? Now IO of 0 plus I have already computed, so VO of infinity will be what? 0, and IO of infinity will also be 0. And again, like, this will be just proportional to my voltage waveform will be just be proportional to my current waveform. So okay, I have just taken this page extra, so this will not be present. So here, right, what will happen is that initially some current will flow, that is some impulsive current will flow, okay, that is of area R. Then what will happen is the current, just keep a note of the current direction. So my current direction was in this is the direction that I wanted the current. So initially the impulse current flow in this direction, that is in this direction, right? But after that, what is happening? Due to this inductor, current is flowing in opposite direction. So now I will get some negative current. And what is the magnitude of the current? Magnitude of the current is minus R by L. So you have to be careful with whatever the interviewer has given you the notation. So you have to go with the notation whatever they have given you, right? So these things also you have to take care of. What will be the voltage? Voltage will be simply proportional to this. Like a voltage will be simply proportional. This will be not. This will be simply a impulse of area 1, right? Impulse of area 1. So impulse current is flowing. Impulse of area 1. This will be R, impulse of area R, then negative voltage, and it goes to 0 again. This is 4 tau. This is minus R square by L. This is 4 tau. Okay. So this will be simply IO of t. IO of t will be simply a impulse current at t equals 0 minus R by L e raised to power minus t by tau. V of t equals to R delta of t minus R square by L into e raised to power minus t by tau, and to be more precise, obviously we will add in a unit step as well. Now what about the poles and zeros? So poles will be same, right? Poles will be same. It will be negative of inverse of time constant. So poles will be same. It will be minus R by L. SP is same. What about the zeros? So this time, right, 0 will occur at what? Again, 0 will occur at S equals to 0, because this will go to 0 again. Okay. If I short this, this will go to 0 again. So at S equals to 0, I have a finite 0. So obviously I won't be able to find the DC gain, because DC gain is simply equals to 0. Because if I at 0 frequency, what is happening? This is short circuited, right? This is short circuited, hence whole current flows to this. So whole VO is equal to 0. So my transfer function is VO over this II, which is 0 equals to, so which is equal to 0, hence this will be 0. So obviously I have to take help of the high frequency gain. So high frequency gain means what? Like if I write the transfer function, right? If I write the transfer function now, H of S is equals to VO over II, which is equals to A into, I have a 0 at S equals to 0, I have a pole at minus R by L, this will be L by R in time constant format. So at high frequency, right, only this coefficient of S will remain, so A by S. So if I draw this circuit at high frequency, this will be open circuit and the whole current will flow through this R, hence my VO at high frequency will be I times R. So H of infinity will be simply I times R divided by I, which is equals to simply this A divided by L by R. So again the transfer function will be same only, that is this SL divided by SL by R. Transfer function will be same, SL. So from here, right, my A will be this same value, A will be L, and transfer function will be H of S will be SL divided by SL by R plus 1. Okay, so this will be my transfer function, and like the Bode plot and all those things will just be similar. Bode plot and all those things will just be similar, they will not change for this circuit. But what you can do is you can find out the transfer function of current output and current input. Generally they ask us the voltage output. You can find out the current output and you will see the current output transfer function has changed this time. Okay, so like I will just skip this now because that will just waste our time, and I will directly go to the next question. Let's start the third one. So in the third one, the difference is we have two resistors, but that won't make much difference. But what difference that will make, we'll just see in a bit. So here again, only one energy storing element is present in the whole circuit. So obviously number of independent energy storing elements will be 1. Okay, and as is 1, I have a single pole. As I have a single pole, that means my response will be exponential. And as my response is exponential, so I will be like there will be a time constant for this circuit. So what is the time constant? Time constant is L equivalent upon R equivalent. So what is the R equivalent this time? So from the inductor, if I observe the R equivalent, L equivalent is L because there is only a single L. But from the inductor, if I observe the R equivalent, right, from the inductor terminals, what R does the inductor sees? So if I open the inductor terminals, and from the inductor terminals I observe the R equivalent. So this R, this R. So the two R's, right? The two R's are in series with each other. Two R's are in series with each other. They are not parallel. They are not parallel. Like here you have to be careful. They are not parallel. They are in series with each other. So R equivalent will be, because why? The current through here is 0. This is open circuit. So this R and current through this R and this R is same. And whenever the current is same, that means the elements are in series. So this will be equals to simply L divided by R1 plus R2. Like initially this was actually R1 plus R2, but obviously for simplicity sake I will make them R equals to R for simpler analysis. So this will be 2R, L by 2R. So time constant will be L by 2R simply. Now let's find out the unit step response. So unit step response, what will happen? Again a 1 ampere current will come across this, and what will happen? Initially the inductor doesn't have any flux, so this will not allow any current. So whole 1 ampere current will flow through this. There will be no current across this, so drop across this will be 0, and a drop of R will come across this whole inductor. This will be positive, hence the inductor will be energized, and inductor will slowly energize as the inductor voltage is positive, hence the inductor current will increase and the energy also will increase. Now what will happen at infinity? This will be at steady state, hence the current won't change anymore, and as the current doesn't change, the voltage drop will be 0. So both R and R are in parallel with a 1 ampere of current source in parallel. So 1 by 2 amperes of current will flow as steady state through this inductor. Okay, so that is what basically will happen through this R and L. So that is intuition. And at infinity the voltage will be R by 2. At infinity the current will be half. At t equals to 0 plus the current will be 0 and the voltage will be simply R. Okay, so now if I draw the do the analysis here, so again it's the same statement that initially inductor has no flux and has just hold on, as the initial flux is 0, hence the initial current will also be 0. Okay, so as this is 0, what will happen is that will this be equals to, so will my IL 0 plus be equals to IL of 0 minus? That will depend on whether the voltage is impulsive or not. So if I draw the circuit at t equals to 0 plus, if I draw the circuit at t equals to 0 plus, this will be replaced with a unit step and this will be open circuit. So this will be simply a 1 ampere of current source. Okay, this will be simply 1 ampere of current source. So what will happen, whole current will flow through this because this is open circuit, hence 0 amperes of current will flow. So this whole current 1 amperes will flow through this and this will be plus minus R. Okay, drop will be plus minus R. Hence I can safely say that this drop is 0, right? This drop is 0. So the VL of 0 plus is finite. This is equals to R. This is finite. Hence this equation will be valid. Now as this equation is valid, what will happen here? What will happen? Inductor current will increase obviously. As it is greater than 0, inductor current will increase, hence IO will also increase. So what is the initial voltage? Initial voltage is again this R only, right? Initial voltage is R because this drop is 0, so that is equals to my VL only. So, and what is the initial current? Initial current is this 0. Okay, and what about the steady state? Steady state, this will, like this is at t equals to 0 plus. Steady state, what is happening? Okay, sorry for that. Steady state, what is happening is that obviously at steady state the rate of change of current will be 0, hence this will be short circuit, 0 volts will happen, and like these two resistors will be in simple parallel. So R not R by 2, 1 by 2 and 1 by 2 amps and 1 by 2 amps of current will flow. Okay, at t equals to infinity. Hence what will be my current? IO of infinity. IO of infinity will be simply half amperes. What will be my VO of infinity? VO of infinity will be simply R by 2 volts. Okay, so these things are simple. So initial current was 0, then it went to half this time. It didn't go up to 1, this went up to half. And initial voltage was what? Initial voltage was simple R and then it reduced to R by 2. It didn't go to just 0, right? So this is R, this is R by 2. This is 1 by 2 amperes. Okay, so this will be 4 tau. What will be the equation for this? The equation for this will be simply I, this is not IL of t, this is IO of t and this is V of t. IO of t is simply 1 by 2 1 minus e raised to power minus t upon tau into u of t. Okay, and what about the voltage? So the voltage, right, V of t is interesting. We have to write it down in terms of infinity and 0 plus, then only you will be able to do this. So at infinity, like it is equals to V of infinity plus V of 0 plus minus V of infinity into e raised to power t upon t. What do I mean? So what is V of infinity? V of infinity is R by 2. So I will write it here first, then I will write plus V of 0 plus. What is V of 0 plus? V of 0 plus is R, then minus what is again v of infinity? V of infinity is r by 2, and this whole thing into e raised to power minus t by 2. Okay, so if I simplify this, what will this become? If I simplify this, what will this become? Just take this at the top. So this will become here r by 2. If I take r by 2 as common, this will be plus r by 2. So r by 2 I can take common. R by 2 I can take common 1 plus e raised to power minus t upon tau. And obviously there is a u of t here. Okay, so this will be my step response. Okay, now let's do the unit impulse response. So what will happen in the impulse case? So again, if we go with the intuition, right? If we go with the intuition, initially this inductor has no flux, so this will not allow any current, but impulse current will appear here, and like that will totally flow through this R, and due to this drop of delta t into R, this whole drop will come across this inductor, as this no current is flowing through this R, so there is no drop in this resistor, so whole drop will come across this inductor, and as whole drop comes across this inductor, this will instantly get energized to what value? It will instantly develop a flux of R. It will instantly develop a flux of R. Then as soon as it develops a flux of R, it will instantly get some current. What is the amount of current? R by L, and that R by L will discharge through this 2 R's, not a single R this time, 2 R's. So this will discharge faster, as impulse will go away at t equals 0 plus. This will be open circuit, hence inductor will get discharged this through the two resistors, and then at infinity the voltage drop will be 0, and as the currents are also 0, hence the overall voltage and current will be 0 at t equals to infinity. So that is the intuitive approach. That's how you explain. Okay, so like the same things here, that initially inductor has no flux. Now will this equation follow? We'll see. Okay, will this equation follow? We'll see. No flux, but at VL0 plus, if I draw the circuit at t equals to 0, not 0 plus, at t equals to 0, t equals 0, this will be replaced with the impulse. And what will happen? This will be open circuit, this will not allow any current, so the current through this will be 0 amperes. Whole current delta of t will flow through this. There will be a drop of R times delta of t, R times delta of t. Okay, so obviously this time my voltage is not finite, it is R times delta of t, so which is infinite. Hence this equation won't be satisfied anymore, they won't be equal anymore. My IL will get instantly charged to what? My IL will get instantly charged to R by L, right? R by L. Okay, and what will be the, like this is my IL of 0 plus, and this is my IO of 0 plus as well. What will be my VO of 0 plus? VO of 0 plus will be simply this, right? Across this R, that is not 0 plus, sorry, VO of 0. VO of 0 will be simply this, that is R times delta of t. Okay, R times delta of t. Now what about at t equals to infinity? At t equals to infinity, if I copy this circuit, right? Not infinity, sorry, at t equals 0 plus. At t equals to 0 plus, if I copy this circuit and draw the circuit, if I draw the circuit will be simply R by L. So this will go, this impulse will go away, right? This impulse will go away. This will be simply t equals to 0 plus so what will happen here is that a drop of what? This is plus minus R by L, this is again plus minus R by L. So what is the drop across the inductor? What is VL equals to this time? So VL, is it negative or positive? How do you compute VL, right? You can simply apply a KVL in this loop. You can simply apply a KVL in this loop, and my VL will be what? So, okay, sorry, this is not plus minus R by L, this is R square by L, right? This will get multiplied because R by L current is flowing through this whole loop. So this is R square by L, this is R square by L. So if I apply simple KVL, right? If I apply simple KVL plus VL plus R square by L plus R square by L equals to 0. VL, this is VL of 0 plus, right? This is VL of 0 plus actually. VL of 0 plus is equals to minus 2R square by L, right? Of course it is negative, but this time the value has changed. This time the value has changed. It is 2R square by L, not just R square by L. Obviously it is negative, hence the inductor current IL will reduce, and at steady state it will go to 0, right? At steady state, if I draw the circuit at steady state, what will happen? Steady state, this will go to 0. Okay, so this goes to 0, so obviously there will be no change in current, so hence the voltage will be 0, hence, right, basically if the voltage is 0, then even if there is some current, right, let's assume there is some I current. If I just draw this KVL loop, so like 2I into R will be simply equal to 0, hence I will be 0. Like that also you can prove. So my IL or IO of infinity will be 0 amperes. My VO of infinity will be simply 0 volts. Okay, so what will happen? Initially there was no current through the inductor. As the inductor opposed the change of current, then a R by L of current was flowing. As it got instantly energized, then it got discharged through the 2 R's. This time the tau will be higher because it is discharging through the 2R, like 2 resistors. That's why it will discharge faster this time. This is R by L. Okay, and this is 4 tau. What about the voltage? So initially a impulse voltage of what? Impulse voltage of R amplitude, R not R area is coming. Then I am getting a negative voltage. What is the negative voltage magnitude? So I haven't computed the VO of 0 plus, right? That I haven't computed. So what is VO of 0 plus? So here, right, this is VL of 0 plus, and what is VO of 0 plus? So VO of 0 plus will be simply this value, right? Simply this value. VO of 0 plus will be simply this value, that is minus R square by L. Okay, VO of 0 plus will be simply minus R square by L. So it will be minus R square by L, and then again it will decay down to 0. Minus R square by L. Okay, so IO of t will be R by L e raised to power minus t upon tau U of t, and this will be same for this as well. My VO of t will be what? My VO of t will be simply R delta t minus R square by L e raised to power minus t upon tau into U of t. Okay, so this will be my voltage expression and current expression. Now let's find out the poles and zeros of this. So pole is simple, it is negative inverse of time constant. It is like SP will be negative inverse of time constant. If you want to know a other method like I was just explained in the first example, that is this is minus, like it was L by 2R, so it will be minus 2R by L, or what you can do is you can make infinite impedance from here. So how do we make infinite impedance from here? So you have to make minus R equals to SL plus R. So your SP will be equals to minus 2R by L. How am I writing this minus R equals to SL plus R? That for that, right, you have to see my realizing poles and zeros intuitively. Okay, for that you have to see my video of realizing poles and zeros intuitively. So this is how am I writing this infinite impedance. Okay, so now for zeros, either we can short the output or short the input, right? Either this can go to 0 or this can go to 0. So can I make this can I make this R0? R cannot go to 0, right? R cannot go to 0. Not possible, right? But this can go to 0. How can I make this 0? If this is equals to negative of this impedance, then overall this impedance will be simply 0, right? So my R plus R should be equals to minus SZ into L. So my SZ, this is minus, right? So minus. So my SZ will be equals to minus R by L. SZ will be equals to minus R by L. Okay, so like which is finite, which is possible, and this is also a finite 0. So obviously I have a valid 0 at S equals to minus R by L. So what is the DC gain? So DC gain will be here some finite value. Okay, this time it won't be 0. So DC gain, right, if I draw the circuit at S equals to 0, what will happen is that this will provide 0 impedance. So this will be 0. Hence what I can say, that my VO will be what? VO will be simply II divided by 2. So VO by II equals to 1 by 2, which is equals to my A value. So what will be my this is my, sorry, not 1 by 2, I by 2 into R also is also there, right? So obviously it can't be unitless. So this has to be R. Okay, so what is my transfer function H of S? H of S will be simply A, that is R by 2, into SZ, like S into 1 by SZ, that is this, right? S L by R plus 1 divided by, if you do this, what will happen here? This will be S L by 2R plus 1. Now if you want to cross check, right, whether whatever you have computed is correct or not. So as number of zeros and number of poles are same, so what you can do, you can find out the infinite frequency gain as well. So high frequency gain. So if I find out the high frequency gain, what will happen? This will be open circuit, this will provide infinite impedance, so all of the current will flow through this. So my VO will be simply equals to II by R. So VO by II will be simply R. So if I put here S equals to infinity, what is happening? S equals to infinity, only the coefficients of this S term will remain, that is L by R divided by L by 2R. So this will get cancelled, and 1 by 2 will get cancelled, and only R will remain. So whatever you have computed is correct. Okay, so like that you can cross verify. So now let's come to the Bode gain plot. So transfer function is this, right? Transfer function is this. If I come to the Bode gain plot, what will be this? So obviously I have a my omega P is L by 2R, and my omega Z, I will just change the colors of this. Omega Z is L by R, right? So my omega P is less than omega Z, so pole will occur first, then 0 will occur. Okay, so and at DC, what is the gain? Gain is R by 2, and as pole is occurring first, okay, just hold on, yeah, pole is occurring first, right? Yeah, L by 2R. So yeah, pole is occurring first, then sorry, I'm wrong, because I have just written these things incorrectly. So omega P will be 2R by L, not L by, that is where I was getting confused. This will be R by L, right? So like the 0 will occur first, then pole will occur, and that is making sense because at infinite frequency my gain is what? My gain is R. At finite frequency my gain is R by 2. So my gain is lower at 0 frequency, or not finite, at 0 frequency my gain is R by 2, and at infinite frequency my gain is R, so it will only increase. Okay, from R by 2 it will go to R. Okay, that's why I have a 0 first, then pole, like you can understand from the Bode plot as well. So 0 frequency gain is what? 20 log R. Then at omega equals to omega z, I'm getting encountering it as 0, right? At first I'm encountering a 0, so I'm encountering a 0, and then what will happen? At omega equals to omega p, I'm encountering a pole. At omega equals to omega p, I'm encountering a pole. Okay, so this value will be what? 20, sorry, this is not 20 log r, this is 20 log r by 2, right? 20 log r by 2, and this value is 20 log r. This will be more than r by 2, obviously, that's why. So here, right, in this region my slope was 0 dB per decade. In this region my slope was 20 dB per decade. In this region my slope is 0 dB per decade, because here I had no 0 or pole. Here I just encountered a 0, that's why that 0 will provide me plus 20 dB per decade slope. Then here I encountered a pole and already I had a 0, so overall effect will be plus 20 minus 20, that is 0 dB per decade. Okay, this will be my Bode gain plot. What will be my Bode phase plot? So if I just take the transfer function, so here, right, at s equal to 0 I don't have a 0, so initially obviously the phase won't be 90. Initially what will be the phase? Initially the phase will be 0. And one thing I have already told you, that omega z is but here what you have to do is, like, omega p is greater than omega z, but what we have to take care of is that omega z by 10 and omega p by 10, 10 omega p and 10 omega z. So that will be a bit complex, so I will just write the things down here. So what is my omega p? Omega p is simply 2r by l. Okay, yeah, I will start with omega z. Omega z is r by l, right? So at 10 times before omega z, that is r by 10l, the effect due to 0 will start. Then what is happening is, if I divide this by 10 as well, this will be r by 5l. So the effect of pole will also come just after that. So effect of pole will also come here, that is r by 5l, because I am dividing omega p by 10, that is r by 5l. Now what is happening after this? After this, right, what I will encounter? I will encounter first, I will encounter r by l. I will encounter this 0, right? I will encounter this 0, that is r by l. R by l. So in brackets I will write everything, right? This will be omega z by 10. This will be omega p by 10. This will be omega z only. And then I will encounter the pole again, that is r by 2r by l. Okay, this will be omega p. Then I will encounter 10 times omega z, that is 10 r by l. So this will be 10 omega z. Okay, and this will be 20 r by l, right? So this is 10 times omega p. After this the effect of pole will be gone, and after this point the effect of 0 will be gone. So in this region, right, there is no 0 or pole present, so an initial phase will be 0 only. There is nothing present, so initial phase will be 0. Now at this point the effect of 0 is coming, and what does a 0 provide? For a phase plot, it provides plus 45 degree per decade. So it will provide a plus 45 degree per decade phase. Okay, then after omega p by 10, the effect of pole will also come. So hence the overall slope will overall slope will be 0. Resultant slope will be 0, because plus 45 minus 45 will be 0. So this will be 0. Okay, so then this will go on until this point. Why until this point? Because at this point, right, the effect of 0 will go away, because 10 times omega z, the effect of 0 goes away. If you are not understanding, you have to go and watch the Bode plot video, how to draw Bode plots. Okay, so effect of 0 will go away after 10 omega z. So overall slope will be what now? Overall slope will be minus 45 degree per decade, because the pole is still remaining, and it will go on until 0. It will end at 0. Why it will end at 0? Because the number of zeros and number of poles are same, hence the like phase at infinite frequency will be simply 0. Both will like this will contribute plus 90, this will contribute minus 90. At the end the slope will be 0. Okay, so the homework for you is finding out this value, finding out what this value is. So in this region this will provide plus 45 degree per decade due to the 0. This will provide 0 degree per decade. This is in degrees, right? This is in dBs, yeah. And this will provide minus 45 degrees per decade. So this will be the solution of this question. Now we'll move on to the next question. Let's start with circuit D. So what is happening in the circuit D? So here, right, I have two inductors, and for simplicity I will assume that both inductance are same, L and L. Okay, so first of all, how many number of independent energy storing elements are here? So how to identify that? In this case there are two inductors, so you might say there are two independent energy storing elements, but no. Just see, if I give this inductor some initial current I1, then I know the current through this inductor. What will be the current? The current will be II minus I1. So the current through this inductor is known. So the current through this inductor is set. If I know the current through this inductor, the current through this inductor is set. So this is not independent, but this is independent, because this can get any L current, like, and vice versa. You can do this for this inductor, and this current will be set. So whenever the current is set, that doesn't count into the independent energy storing elements. So here I have only one independent energy storing element, because if I give this inductor, I'll just make this a bit bigger. If I give this inductor some I1 current, then this current, right, this current is fixed, that is II minus I1. This is fixed. So if this is fixed, then the voltage will also be fixed, and current the independency won't be there. So this is the first order circuit, so I will have a single pole. My response will be exponential, and what will be the time constant of this exponential response? So like time constant is what? L equivalent to R equivalent. So how to find L equivalent and R equivalent? So what you can do is, you can find the equivalent inductance seen from the equivalent resistance. So obviously, for finding equivalent, right, we make the independent sources 0. In this case we have a current source, so we will make the current source 0, and I will find the equivalent inductance from the resistance seen. Okay, so what is the equivalent inductance from the resistance? LEQ. It is basically these two are in series, right? These two are in series as same current is flowing, hence L equivalent will be 2L. So my tau will be 2L by R. This will be my time constant of the circuit. Now let's come to the unit step response. So initially, like, how will you go with the intuition? So initially, both inductors don't have any flux in them, so they will not try to change the current, that is zero current. But what will happen is, this current source has a current of 1 ampere, and this current source will try to flow 1 ampere through here. It has to somehow flow 1 ampere anyhow through this, right? And both of the inductors are saying, no, I won't allow any current to flow. So someone has to sacrifice, someone has to compromise. Just like in a relationship, someone has to compromise. So here what will happen is that like, this inductor will provide very high impedance at t equals to 0. This inductor will also provide very high impedance, as this is behaving like an open circuit. This will allow no current. Then what will happen? Both are providing infinite impedance, and this R can be ignored, because in infinite impedance in series with a finite impedance, I can ignore that finite one. So R is ignored. So both are in parallel, and both are providing same inductance, and both are providing infinite impedance. So both will be in same order, and both values are L and L, hence the current will be equally divided, 1 by 2, 1 by 2. So a 1 by 2 of current instantly flows through the inductor. 1 by 2 of current instantly flows through the inductor. So current suddenly change, and if the current suddenly change, that means there must be a impulse voltage that has been applied across the inductor. Who has applied that voltage? This current source, because this current source has to flow that 1 ampere of current. So this will do anything. Like in a relationship, someone is, let's say if someone is in mad love, right? So he will do anything to make it work. So this current source will just provide a voltage of how much? Delta into L by 2. This inductor will provide a voltage of delta into L by 2 that we will just derive, and after providing that, the current through this will be set, that is half and half. After that, what will happen? After that, what will happen is, slowly at steady state, all of the current will flow through this, and none of the current will flow through this. Why? Because at steady state, what is happening is that like this current flows, right? That this current is 1 by 2, 1 by 2. Now this develops some potential here. Now as this potential is developed, okay, this resistor, right? This resistor will try to reduce the potential, because like if the current through this increases just in a bit, the current through this increases, the current through this decreases. As the current decreases, the potential of this R also decreases, and overall potential VO also decreases. So overall this VL also will reduce. So the potential for this is reducing, the potential for this is increasing. So and at steady state also, you can draw the circuit that this will become short circuit and this will also become short circuit, and like current right chooses the least resistive path, so this will choose this path and not this path. That's why at steady state, this will, like through this inductor, the whole current will flow, and through this zero current will flow. We'll see this. Okay, so this is the intuitive approach. That's how you should go. That's how you should go. Okay, explaining things. So let me draw the circuit over here. So initially inductor has no flux. As it has no flux initially, it will obviously have no current. Now in this case, will my IL, this is IL, right? Will my IL 0 minus will be equals to IL 0 plus? Let's see. So if I draw the circuit at t equals to 0, if I draw the circuit at t equals 0, this is a unit step. This will be replaced with 1 amperes, and this is some I1 and this is some I2. So one relation is fixed, that KVL cannot be violated. So sorry, not KVL, KCL cannot be violated. So my I1 plus I2 has to be equals to 1 ampere. This has to satisfy. Okay, next, but this inductor, both of these inductors are providing very high impedance. So what I can do is, I can ignore this R, because infinity plus 2 is infinity. That's why. Okay, because this is infinite impedance, I can ignore this R. This R is some finite value, so this R I can ignore. Right now L and L are in parallel, and both of them are providing same impedance. So what will happen? The current will get simply divided. You can apply the current division rule, or you can solve using the Laplace as well. Okay, so here my I1 will be 1 by 2, I1 equals to I2. Sorry for the noise. I1 equals to I2 equals to 1 by 2 amperes. Apologies, I had to actually pause the video because there was some noise coming out from outside. So this I1 and I2 will be equals to 1 by 2. Now how should we proceed? This both inductors, right, have 1 by 2 of current with them. So what will happen is that, and what is the potential that they are? So what this I2 means? I2 is basically this IL 0 plus, right? IL 0 plus. So this is 1 by 2. So this has gone in very small amount of time from 0 to 1 by 2. So obviously impulse voltage have been applied. How can you find out the value of the impulse voltage? What you can do is, what do you know? My I is equals to IL is equals to L delta I, not VL. VL is equals to L delta I into delta T. Now this delta T is very small. Delta T is tending to 0. Delta T is tending to 0. In our case, limit as delta T tends to 0. Okay. So now what will happen? I will just put this in the next slide. So what is delta I? Delta I is this, right? Delta I is limit as delta T tends to 0, 1 by 2 minus 0. So final minus initial divided by delta T. Now as now L is obviously here, L I can take outside the limit value. So this will be what? L into, if delta T is very small, right, what is happening? This is like a infinite, and the magnitude will be half. So in infinite value, so not magnitude, area will be half. So this will be L by 2 into delta of t. Okay, this is how we define the impulse, right? If you have studied the definition of impulse, this is how we define the impulse. Okay, so a very high value is applied within a very small amount of time, delta t. Now this is the voltage that has been applied across the inductor, and this is my VL of 0 plus. So obviously this won't be equal, as this is not finite. Okay, not finite. Okay, now what next? What is next? Next is for t plus greater than 0, what is happening? T greater than 0, what is happening? So for t greater than 0, if I analyze the circuit, this is flowing half amperes of current, and this is also flowing half amperes of current. Okay, half. So what will happen? Let's name this as VO, and let's name this as like this as VL, right? This voltage as VL. Okay, and this is at t equals to 0 plus. Now what is happening? If I just draw, like, what is VO equals to? VO is equals to R by 2 plus VL, right? VO is equals to R by 2 plus VL. Slowly what will happen is, once this inductor will try to energize more, this inductor will try to reach more steady state. So VO will reduce, and if VO reduces, what is happening? This current is also reducing, right? So this VL will also try to reduce, because this inductor will also, everything will try to go to steady state. So if everything tries to go to steady state, this voltage will also reduce. So all of them will try to go to steady state. And at steady state, what will happen? At steady state, if I just draw the circuit at steady state, because like both inductors, they like to be in steady state, they don't want any change in current. So if they don't want any change in current at steady state, the change in current, that is DIL by dt, will be 0. And if this is 0, that means my voltage across the inductor will be 0. So this will be short circuit, and this will be also short circuit. So if this is short circuit, right, hence what is happening? This total voltage is 0. Okay, if this total voltage is 0, then like voltage across the R is also 0, because voltage across this is 0. So voltage across R will be 0. If voltage across R is 0, this will be 0 amps of current. Hence whole current will flow through this, that is 1 amps of current, right? 1 amps of current. This will be 1 amp. Okay, so yeah, this is also 1 amps. So what can I say? That my VO of infinity will be what? VO of infinity will be simply 0. My this VL of infinity, like whenever I say VL, right, it means the inductor on the right hand side, because this VO is equals to VL on inductor on the left hand side. So this is 0. My IO of infinity also is what? 0, right? Because no current is flowing here, and IO I am measuring through this. Like this is my IO of infinity, or I can say this is my VL2, and this is my equals to VL1, right? And this is my IO of infinity, or equals to IL2. So infinity. So these are the things. Now VL1 will do. All these are set, right? Now let's just draw the plots. So what is happening? Initially the current across this connector was 1/2. Then it got reduced. Why? Because current was reducing, because it tried to go to steady state, and a steady state, what is happening? 0 amperes of current is flowing. So obviously this will start from instantly, it will change to half, and then it will go to 0, decay down. So this will be half, and it will decay down to 0. Then VR, what about VR? VR will be just the replica of this, right? VR, the voltage across the resistor, will just be the replica of this, that is R times this, because current into resistance is voltage, they are proportional to each other. So this will be R/2 simply, and this is 4 tau, and this is 4 tau. Now what about the inductor voltage, right? Inductor voltage, that is VL2. In our case, that is simply L. So I told you, right, initially impulse is getting applied to change the current instantaneously. So this will be L/2, area of L/2. Now how do we found out that this will go to some negative value, right? This will go to some negative value. Okay, then it will decay down to 0. Why this will go to VL2 will go to negative? Because it has to discharge, right? It has to de-energize. Then only the voltage will be negative, hence the current will reduce. How do you find out that? So here you can write a very good equation, not this, okay, this equation. Let's name this as VL1, okay, VL1, and let's name this as not for now, this is VL2, right? This is VL2, sorry for that, VL2, and let's name this as VL1. Okay, now let me define here the currents, right? This is the IL1 and this is the IL2. IL2. Okay, so what I can write a KCL equation, right? And that will be always satisfied that 1 is equals to IL1 plus IL2. That means what? That if I differentiate on both sides with respect to time, 0 equals to dIL1 divided by dt plus dIL1 not IL2, so dIL2 divided by dt. So from here what can I conclude? I can conclude that my dIL1, okay, I don't have enough space unfortunately. Can I just hold on, huh? Here my dIL1 by dt will be equals to minus dIL2 by dt. Now if I multiply L on both sides, because the inductance are both values are same, but where they would have been different, things would have been bit different over here. Okay, the rate would have been bit different. So if I multiply this by LL, what is actually happening? That my VL1 equals to minus VL2, right? Because L dit dt is equals to voltage across the inductor. So now what I can do is I can just copy this thing again, okay, and paste this over here and like use a circuit again and write the KVL. From this also you can intuitively understand that why is it reducing, because one voltage is positive, one voltage is negative, right? If I just assume any number, let's assume VL1 as +1, then this will be negative, that means this will decay. If I assume VL1 as -1, then this will be positive, then VL2 will energize. So one is energizing, another one is de-energizing, and the rate of energizing and de-energizing are same over here. Just proved here. I just proved over here, right? So what can I write? I can simply apply a KVL in this loop. You can apply a KVL in this loop. So what is a KVL? So minus VL1 plus, like there is a half, like what is the current that is flowing right now at t equals to 0 plus, the current that is flowing is 1 by 2. So what is the drop across this resistor? It is plus R by 2. Then again plus VL2 equals to 0. Now I will just assume this as a number equals to, this is equals to what? I will assume this is equals to VO, right? I can assume VO or VL1, anything. So if I assume this as VO, so this will be minus VO and this will be also minus VO equals to minus R by 2. So VO will be equals to plus R by 2. So hence VO is positive, that is my VL1 is positive, okay, and my VL2 is negative. That means this will energize and the current will increase, right? Current IL1 will increase, and here, right, this will de-energize, and here the current IL2 will decrease, right? So from this also you can intuitively understand what is actually happening in the circuit. So this value will be what? VL2. VL2 is what? At t equals 0 plus, it is minus R by 4. Okay, it is minus R by 4. Yeah, minus R by 4, because VO is R by 4, VL1 will be minus R by 4, then that overall KVL will be plus R by 4. Okay, so yeah, VR is R by 2. Yeah, all these are sorted. Now how to plot VO? VO will be what? VO will be initially, like here, right? VO will be initially, like there will obviously be an impulse coming across. Okay, what is the value of the impulse? Value of the impulse is L by 2, right? L by 2. So value of the impulse will be L by 2. If I can use some other color, value of the impulse will be L by 2. Then it will be just the voltage drop across the first generator, right? What is the first generator? First generator, it instantly got a voltage of R by 2 L. I'm sorry, not just R by 2, and then it decayed down to, not R by 2, sorry, R by 4. Then it got decayed down to 0. So this is my 4 tau. Okay, and this is also my 4 tau. Now I can write down the equations. So if I write down the equations, right, what will be the equation? So this will be what? This will be simply IO of t will be 1 by 2 e raised to power minus t upon tau u of t. Okay, that is equals to my IL2. Then VR of t is equals to my R by 2 e raised to power minus t upon tau u of t. What is my inductance? Second inductance value, it is VL2 of t. 2 of t is equals to L by 2 delta t plus, not plus, minus R by 4 into e raised to power minus t upon tau into u of t. And what is my VO of t? VO of t is equals to L by 2 delta of t plus R by 4 e raised to power minus t upon tau into u of t. Now can you cross verify? What is the cross verification? Cross verification is that my VO of t should be equals to my VL2 of t plus VR of t. Is it true that initially there is no impulse, just this R by 2 value is there, and if I add R by 2 minus R by 4, I will get R by 4. That is correct. Okay, so R by 4 I am getting at just at t equals 0 plus, this value is R by 4, right? And at t exactly t equals to 0, I am getting an impulse of plus L by 2, which is again correct because I am getting an impulse of plus L by 2 in this inductor. So everything is correct. If all the equations that I have derived here, all of them are correct. Okay, so this is a very great analysis. So please do rewatch it again, because this type of concept can be asked in future interviews and future questions, right? So these type of questions can be asked. So let's now do the unit impulse response. So unit impulse response will be very interesting, and only for this analysis I will just expect a like from you, because trust me, no one will do this type of analysis, intuitive analysis like before this. No one has done this, and no one will be able to do this. With Laplace it will take you 30 minutes to 1 hour to at least solve this. Okay, with Laplace, but no one will tell you how to solve this intuitively. So I will just expect this one like from you, because no one will upload this type of content. But after this, obviously everyone will copy this, so obviously everyone can say that okay, I know this concept from previous times, but this is the first time that this will be like present in YouTube, right? So here what is happening, how do you do the unit impulse response? So why is it difficult? Because a impulse current is flowing across the inductor, and whenever an impulse current flows across the inductor, things become very, very messy and difficult to analyze. So obviously L and L are same. So intuitively what will happen is impulse current is present. Okay, initially at t equals 0, impulse current is present, and same thing as the previous case, unit step response. This both inductance will provide infinite impedance, hence this R will be ignored. Now half current will flow through each of them. Okay, what is the current? The magnitude of the current, or the value of the current is delta t by 2. Delta t current will flow each of them. What will happen? The inductors will develop a voltage of doublet function, that is delta dash into L divided by 2. That will be the developed voltage across the inductor at t equals to 0 due to this current source. This current source will again give them a doublet voltage, right? Doublet voltage. Differentiation of impulse is doublet. Now next what will happen? Next, just at t equals to 0 plus, this impulse current will go away. This impulse current will go away. Then what will happen? This inductor has some current with it. This inductor has some impulse current with it. It will try to flow. Where it will flow? It will flow through this resistor. This resistor will be provide some drop, and that drop will be the discharging drop of both these inductors. Again, the charging and discharging of both these inductors will be same, and that drop will be equals to what? This current was what? Delta t by 2. What is the drop? Delta into R divided by 2. Okay, so delta into R divided by 2. What will be the voltages? It will get divided. It will be simply divided because rate of charging and discharging are same. So it will be delta into R divided by 4L. Okay, for one case it will be positive, for the other inductor it will be negative. Okay, one will energize, one will de-energize. I will explain also how one is energizing and how one is de-energizing, because there is no source here. How is it energizing? I will explain that also as well. Okay, so next what is happening is that again another drop is formed. Like the inductors, impulse voltage is getting applied across the inductors. What will happen? Instantly it will change its current. To what value it will change its current? It will change its current to what? The voltage is delta R by 4. So current will be 1 R by 4L. R by 4L. R by 4L will be the current at t equals 0 plus, because if a impulse voltage, if the value of the voltage is R by 4, then the value of the current R by 4 delta t, then the value of the current will be R by 4 into R by 4L, right? R by 4L, because if impulse voltage is getting applied, the current will change instantly to some unit step. Integration of impulses step. That's why the current will get instantly changed to R by 4L. Then after R by 4L, what will happen is everything will go to 0, because this will try to reach steady state. So the voltage, the change in current will be 0. So the voltage will be 0 here. The voltage will be 0. And if the voltage is 0, the overall voltage across the R is also 0. Hence the overall current is also 0. So this is the intuitive approach. Okay, and like don't worry, if you didn't understand, don't worry, you have to see the analysis, then only you will be able to understand, because to understand this intuitively it took me much long time. Okay, so now the same things, the first line will be same only. Okay, first line will be like first steps will be same, that initial flux is 0. Now if initial flux is 0, initial current across the inductor will be 0. And what is I1 plus I2? If I draw the circuit, right? If I just draw the circuit at t equals to exactly at t equals to 0. This current is what? This current is delta t. And obviously this resistor can be ignored as both of them are providing high impedance. So this is at exactly at t equals to 0. So this will be delta t by 2 and delta t by 2 basically, because obviously both of them are providing equal impedance. So this will be delta t by 2. Else they would have divided in terms of their inductance, as both of them are same. This will be delta t by 2. So obviously here my summation will be delta t, and each currents will be delta t by 2. So IL of 0 plus is what? Delta t by 2, which is definitely not equals to IL of 0 minus. Why? Because if I just compute the voltage, right? Okay, what will be my voltage? My voltage will be simply Just hold on, I will check if everything is recording or not. Yeah, everything is recording. My voltage will be basically VL, right? Let's understand VL. What is VL? VL is LDIL by dt. LDIL by delta t. Here, right, the current is changing at a very small magnitude of time. So I will say limit as t tends to 0. Limit as t tends to 0, or as delta t tends to 0. Okay. It is L. What is delta L? Like it changed from a 0 current to a impulse current, right? That is delta t by 2. Delta t by 2 minus 0 divided by delta t. So what will be this? So this will be the differentiation of this, right? What is the differentiation of an impulse? It is a doublet function. It is a doublet function. So it will be VL2 will be L into delta dash by 2. Okay. So this will be my like voltage across the inductor at t equals to 0, which is obviously definitely not finite. Hence, obviously, I am getting an infinite voltage. So not finite. I am getting infinite voltage. Obviously, the inductors will get instantly like energized to this particular current. Now, after at t equals 0 plus, what is happening? The impulse is gone, right? Impulse is gone at t equals 0. So this will provide a 0 amperes of current. This will provide a 0 amperes of current. But these inductors are still energized. What are the value of those inductors? How much current do these inductors possess? That will be defined from this register, right? From this register. Why? Because the current at t equals to just after t equals 0 plus, right? What is the current? Current is what? Delta t by 2L. So not delta t by 2, right? Current is delta t by 2. So I of 0 plus is delta t by 2. So what I can say is my same thing I will do, that 0 is equals to IL1 plus IL2. What can I say about this? Then I can say that IL1 will be equals to minus IL2. Hence, I can say VL1 will be equals to minus VL2, as L1 is equals to L2. All these things I can say, right? Let's reduce the size of this. Okay, so as L1 is equals to L2. Now, what I can do? I can apply a simple KVL. If I apply a simple KVL, what will I get? So, if I apply a simple KVL, just copy this circuit. This will be minus VL1 plus this VR, right? VR is, I will say what is VR, and plus VL2 equals to 0. So what is my VR? VR is simply I into R. What is I? I was delta T by 2 into R, right? This is what my I was. So I can say my this, like, what is VL2? VL2 is minus VL1. So minus 2 VL1 equals to minus delta T by 2 into R. Okay, so my VL1 is what? VL1 is plus delta T by 4 into R. Okay, so a impulse voltage is getting applied across the inductors. I am getting an impulse voltage across the inductors. And what does a impulse voltage means? That means a step current. I will integrate impulse, I will get a step. So what will be my current? IL1 at 0 plus. Okay, so this, right, this current is not at equals to 0 plus. This is exactly at equals to 0. This is exactly at equals to 0. So at exactly equals to 0, this is happening. So this is not the 0 plus current, this is the 0 current, right? 0 at t equals to 0. So here IL1 0 plus will be what? IL1 0 plus will be simply the integration of this, right? Will be simply the integration. What is the integration? So the integration, this is IL1, right? IL1 integration will be R by 4L, right? I'm integrating an impulse, I'm getting and dividing by inductance, I will get R by 4L, and U of t, I will get a step current. Okay, then what will be IL2? So remember this, right? So VL2 is what? VL2 is negative. VL2 is negative. So delta T by 4R. So again, this is impulse, but this is negative, right? Negative. So my IL2 of 0 plus will be what? IL2 of 0 plus will be minus 4 by 4L. And this is also satisfying, right? Because here, whatever current I'm getting, right? These two are in series now. All these components are in series now. So if, like, I'm assuming this is the direction, positive direction for this current. So I'm getting a positive current, since current is flowing in this direction. So it should flow in the opposite direction as respect to this IL2, because current should be in series, and if this inductor is telling current to flow in this direction, then but this inductor is telling current to flow in this direction, then obviously both are dissatisfying. There will be again a impulse voltage developed. But what is happening? This is a negative current, so I have assumed this has the positive direction, but as is negative, current will actually flow in this direction. So current flows in this direction. So current flows like this, okay, and both are satisfying. Everything KCL, KVL, everything is getting satisfied over here, right? So another thing is that obviously this will be positive and this will be negative. So if one energizes, another one will de-energize, right? One will energize, another one will de-energize. So obviously if this energizes, this will energize. If this is positive, I don't know if this is positive, this is positive, and if this is negative, this will de-energize, right? So here, right, one thing you have to understand is at steady state what will happen. At steady state, everything will go to 0. But I have to again draw the voltages across the inductor. Now what is the voltage across the inductor? From that I will only be able to understand which one is de-energizing and energizing. So again this equation will be followed again. This equation will be followed again, right? The same thing will be followed at t equals to 0 plus again. Look, a lot is happening, right? A lot is happening. So you have to just sit patiently and watch everything in focus. So now what are the currents? The currents, right? If I just replace them with current sources, this, let's name this, okay. The direction of current is something like this, okay. So and voltage I have assumed like this, plus minus, okay. So this was the initial voltage. So this is what current? This is R by 4L. This is also R by, just use some other. Okay, so now what is the potential? The potential again, right? If I just again simply apply a KVL, again minus VL1 plus VR plus VL2 equals to 0. Now what is VR this time, right? Current is flowing in this direction, but VR is like this, plus minus. So obviously VR will be minus R square by 4L. Okay, so my V minus 2VL1, right, should be equals to plus R square by 4L. So VL1 will be equals to minus R square by 8L. Now what does this mean? What does this negative means? Okay, this negative means that this inductor is discharging now. This voltage is negative. That means the current is reducing. Whatever the current was, right? Current was here, right? But the voltage is negative. Hence the current is reducing now. Current is reducing for this. So the direction of current is this. It is R by 4L. It is reducing from R by 4L to some value, because here my IL1 will reduce, because here my IL1 will reduce. Okay, now what is the next thing? Actually I should have drawn this a bit wrong. I should have drawn this polarity correctly. What I will do is I will write this polarity like this, because this was the initial polarity that I assumed, and with respect to this polarity only I will compute everything. So my current was negative for this case, right? It was minus R by 4L. Now for this second one, right? For this second one, my VL2 is positive, because as VL1 is negative, obviously as VL2 is minus of VL1, VL2 is positive. Now you might say, sir, current is increasing. You might say, sir, if VL2 is positive, then you will say, sir, current is increasing. Yes, you are correct. Current is increasing. Current is increasing. But how can current increase? There is no source. How can current increase? The main point is it is increasing from this negative value. Okay, it was negative. Current was already previously negative. Current was negative already. IL2 was already less than 0. So it is increasing and going towards IL2 equals to 0. Okay, if I have negative number, right? Minus 5. If I say I'm increasing from minus 5, that means what? I'm going towards 0. I'm going towards 0, right? 0 will also come in between. I'm going towards 0. So IL2 is increasing, yes, but it is increasing from negative value. But and IL1 is decreasing. It is decreasing from a positive value because initially IL1 was positive and IL2 was negative. So this will increase from negative value and this will decrease from positive value. IL1 will decrease from positive value, IL2 will increase from negative value. So I hope you understand what does the voltage mean. Yes, energies are reducing in both the cases. Energies are reducing. So obviously this term, right, exactly this energized term and de-energized term, I cannot here specifically say. Okay, I cannot say here specifically because I can just say the flux is reducing. So here, right, the flux, whatever flux it gets, if the flux is positive for this case, then the flux will reduce. If the flux increases for this case, then the flux will reduce. Okay, and the direction also you have to take in factor. Okay, so as is a source free network, there won't be any energy present. Just due to the impulsive nature, I will get some energy. Okay, so this energized de-energized term will also be wrong here because this is source free network. So let's do the plot now. So like what will happen at steady state? At steady state, if I draw the circuit again, at steady state, the voltages will be 0, right? Because dIL by dt will be 0, so hence the voltages will be 0 across this. This is again VL1 and VL2. I don't know what is the value of the current. I will determine the value of the current I. Let's name this current as I and let's name this current as also minus I, right? Minus I. And again the same relation follows. The relation will always follow. What is the relation? That VL1 will be equals to minus VL2. So if I do apply the KVL now, minus of VL1 plus this will be plus minus of VL1 plus VR plus VL2 equals to 0. So VL1, I can say minus 2 VL1 equals to minus of VR, and VR is what in this case? I don't know. I have to find out the VR, right? So VR is equals to 2 VL1, and what do I know? I know that it has reached steady state. So at steady state, this is at t equals to infinity. This is at t equals to infinity. At steady state, what can I say? At steady state, I can say that VL of infinity will be 0 as the rate of change of current dIL by dt will be 0, right? It has reached steady state. So I can say I into R equals to 0. Hence I is equals to 0. Current will be 0 and everything will go away. The VL will obviously be 0. VO will obviously be 0. Everything will go to 0. So now let's do the plots. So initially, what is happening? Initially, what is the IO? I am getting an impulse current. Not impulse. Yeah, I am getting impulse current delta. That is the of area 1 by 2, right? 1 by 2 delta of t. Then after that, what is happening? I am getting a step current, right? After that, I am getting a step current of what value? Of value, and that is at the negative direction. That is at the negative direction. Of what value can I say the value of this? The value is minus R by 4L, right? Minus R by 4L. Then it is decaying exponentially. Why? Because this is a first order circuit. This is a first order circuit. That's why this is decaying exponentially. Because for a step response, the response will be exponential. Okay. What is the voltage across the resistor? It will just be proportional to the current, right? Just be proportional to the current. So it will provide me R by 2 delta of t. Okay, R by 2 delta of t. Then again, I will get this value as R square by 4L and it will go towards 0 in what time? 4 tau time. In 4 tau time. Now let's plot the VL2. That is the inductor voltage. Inductor voltage is really interesting. So as I told you, right, impulse current is flowing at t equals to 0. So the voltage will be doublet. The differentiation of that. So voltage will be simply a doublet of what value? L by 2 delta dash into t. Then again a step current. changes, right? The current across the inductor changes to a step. So the differentiation of the step will be simply this, right? And what is the magnitude of that step? Like initial jump of the step was r by 4l. So it will be r by 4 delta dash of t. Then what will happen? Then what will happen is it will decay down. Like current was like voltage was like this. VL2 will be positive only, right? Because VL1 I derived that VL1 is negative. Okay, VL1 is negative and VL2 will be positive only. VL2 will be minus. This will be minus not minus, plus r square by 8l, right? Because this was minus, this will be plus. So it will reduce from plus r square by 8l to 0, decay down in photo time. Okay, so this will be in photo time, and this will be plus r square by 8l. Okay, so can I write the equations for this? So like let me just draw the VO. VO will be simply VL2, right? VO will be simply VL2, and for VL2 as well, initially a doublet voltage is getting appeared across the source, across the inductor. So this will be L by 2 delta dash of t. Then a impulse is getting appeared across the inductor. What is that value of the impulse? It is simply r by 2. Just hold on. Yeah, this is correct. R by 2 by 2 dash by 4. Yeah, by 2 delta of t. Correct. Am I doing something wrong? I'm just assuming something. Okay, I made a mistake. This should be negative, right? This should not be positive. Why? Because here, right, at t equals 0 plus whatever, this is not delta dash again. This is just delta. Sorry for that. And this was negative, right? This should be negative of this voltage. Why? Because I assume, right, if my VL1 is positive. So here, right, what was my VL1? VL1 was this. Okay, this impulse voltage is coming across this, and impulse will get applied instantly. Not here. I will just check here. Yeah. Okay, this is impulse voltage. This is a VL1. VL1 in this case is positive. If VL1 is positive, right, so VL2 will be negative. Yeah, VL2 will be negative, minus r by 4l. Okay, so this will be minus r by 4l, not plus r by 4l. Apologies for that. This should be minus r by 4l. That is mistake. Okay. Okay, this will be minus r by 4l delta of t. Okay, then again it will, like, this voltage will change, and then again de-energize. So that was a mistake on my behalf. I'm sorry for that. Okay, so this is happening. Now what is VO, right? This will be plus r by 4l delta of t. Oh, sorry, not L. This will be r plus just r by 4, right? Yeah, this will not be L. Sorry for that. This will just be r by 4. So I'm messing up a bit here. This should be r by 4, right? Yeah, this should be, yeah, r by 4 delta of t. So this will be r by 4 delta of t. Okay, and then what is happening? Then the voltage is getting negative because this is the voltage across the inductor L1, VL1 of t. So this will go to negative, and this will decay down. So what negative value this goes to? This goes to minus r square by 8l. Okay, and this is photo. Okay, this is photo. Correct. So this is the plots for this. Now can you cross verify? We will cross verify, right? How will you cross verify? I will just show you. So what is the equation of current? What is the equation of current? So equation of current will be I of t will be equals to delta t by 2 minus r by 4l into e raised to power t upon tau into e of t. What will be the r? What will the voltage across r? It will be just be a simple multiplication with r over here, right? Simple multiplication with r. So this will be same. VR will be same, right? Just a scaled version. This will be VR and this will be just be scale. This will be r by 2. This will be r square by 4l minus r square by 4l. Okay. What about VO? So sorry. What about VL2? What about VL2? So what will be my VL2? So if I want to compute my VL2, right? If I want to compute my VL2, I am getting a lots of things. Lot is happening in this circuit. Okay. Just as sometimes in a relationship, sometimes a lot of thriller happens and sometimes nothing happens. It's just boring. So just joking, by the way. So here this is L by 2 delta dash of t plus r square by 8l. First I will write the impulse. So impulse is minus r by 4 delta of t, this is delta dash, and this will be plus r square by 8l e raised to power minus t upon tau. Okay. Now you can cross verify, right? You can what you can cross verify. What you can do is you can differentiate this. This is the current. Right? If I differentiate this, this will be delta dash by 2, and I have to multiply L. That is delta dash by 2 multiplied by L. So this first term is coming out. Then if I differentiate this, right, I will get two terms. One will be this step, like differentiation of this step. Another one will be the simple differentiation of this. If I differentiate this step, right? If I differentiate this step, what will I get? I will get an impulse. I will get an impulse of magnitude what? R by 4, right? Of R by 4, because R by 4L, because like that's how we make this magnitude 0, right? We make the magnitude of the impulse 0, make it t equals 0, and that is my magnitude. So I am getting R by 4, and I have to multiply L as well, so this LL will get cancelled. Okay, that's why I am getting R by 4. Okay, if you are not able to understand, don't worry. This is in the signals thing. Now if I this is chain rule, right? First I differentiated this and kept this as constant. Now I will differentiate this. If I differentiate this, what will I get? So what is the time constant? Time constant is R by 2L. R by 2 2L by R, right? Time constant is 2L by R. So this is what? This is, if I write this is 1 by 2 tau, right? 1 by 2 tau, and I have to multiply a minus okay, just hold on. If I differentiate this, this will be minus 1 by tau. Sorry, this is not, actually I made a mistake. This should be tau is here, yeah, 2L by R. So this is 1 by tau, correct only. Okay, yeah, 1 by 2, and there is minus 1 by tau as well. So this is minus 1 by 2 tau square. So what is tau square? It is minus 1 by 2 into 4 L square into R square. Now I will multiply L with it because voltage is L dIL by dt. If I multiply L with it, so this will be minus R square by 8L, which is exactly the coefficient here, right? And obviously there is a minus sign. Like there is already a minus sign over here. So this minus and minus, right? If I differentiate this, minus and minus will get plus. So like if you don't understand, don't worry. I'm just doing this in short. Just like differentiate this, right? Because the voltage across the inductor will be differentiation of its current multiplied by L. So just wanted to prove that whatever we have done is correct. That's how we can do a quick sanity check. Whatever we have done is correct only. We have done nothing wrong here. Okay. So what will the expression for voltage? Output voltage. The expression for output voltage, right? If I have some color, I'm not able to find out good combination of colors. So this is L by 2 delta dash of t plus R by 4 delta of t minus R square by 8L e raised to power minus t upon tau. Okay. So this will be my voltage. Now is this correct? Is this correct? How can you verify? How can you verify? You can write VO will be equals to, first is VL1 equals to VR plus VL2, right? If I just add these two, right? So first of all, is there any delta dash term over here? No, right? So only this will be present. So if I add this, this will be L by 2 delta dash of t, correct? Then is there any delta of t? Delta, this is minus 4, like coefficient is minus R by 4 and coefficient here is R by 2. So R by 2 minus R by 4 is plus R by 4. I'm getting plus R by 4, correct? Then what is the coefficient of e raised to power minus t upon tau? So here the coefficient of e raised to power minus t upon tau is minus R square by 4L. Here it is plus R square by 8L. So overall it will become minus R square by 8L. So yes, this is correct. So whatever I have proven, right? Whatever I have proven is correct. So this I will just write as unit step. Okay. Unit step, this will be U of t. So this is a very interesting like discussions. You should watch this again so that you are able to grasp everything whatever I have told you. So you should watch this again. Okay, so everything here, this will be u of t actually. This will be u of t. Okay, and yeah, this is u of t. So now let's like find out the poles and zeros. So now let's compute the poles of this. The poles, again, this is the first order circuit. So simple poles will be negative of the time constant. So this will be minus 1 by 12 by r, that is minus r by 12. This will be the poles. Or what you can do is you can make infinite impedance here. And if you want to make infinite impedance here, just you have to write SL equals to minus r plus SL. So your 2SL or your SP will be equals to minus r by 12. Like that also you can solve. Okay, either way. So now let's solve the zeros. So what are the zeros? 0 for zeros, right? Either you can short the output or short the input. So can I short the output? Yes, right, I can short the output. How can the output be shorted? How can the output be shorted? The output can be shorted at r equals to, we'll write here, short the output. So I can write this as, like, I'm shorting this currently. I'm shorting this, right? How would I short this? This will be SL, okay, should be equals to minus R. So I have got one zero, that is minus R by L. Do I have any other zero? I think I have another zero, because at S equals to 0, right, this is going to provide zero impedance, and this is finite. This is non-zero. This is non-zero. Hence what will happen is the whole current will flow through this, and hence the drop will be also zero. So at, like, this is short the input, right? Short the input. I was shorting the output. Now I am short the input. Is equals to 0, right? Why? Because SL is going to 0, SL1. So here I have two zeros and I have one pole. So you might have a question how this is realizable, because just in the start of the lecture you told that if number of zeros is more than number of poles, your transfer function won't be realizable. Like, that was conditional actually. I didn't mention that one condition, that it has to be of same units. Okay, if it has to be same units, because if let's say it was VO upon VI, so I cannot give finite current and get infinite current, right? And I cannot get finite voltage and get infinite voltage. That is not possible for a realizable practical circuit. But here what is happening actually, my transfer function, right, is VO upon II. VO upon II. So if my transfer function is VO upon II, that is actually the unit of ohms, and I can get infinite impedance. That is possible. I can get, practically possible, I can get infinite impedance at infinite frequency. Okay, so as the unit is ohms here, so that is still practicable. Okay, that is, we're not talking about the gain here, we're talking about the transfer resistance. So that is fine, that can go to infinity. So this will be practically realizable. But for simple ratio, right, voltage ratio, current ratio, the gain cannot go to infinity. That's why the it won't be a practical amplifier. That's why we say that number of zeros should be equals to or less than number of poles. But in this case it can be more, because we're talking about impedance, we're talking about the voltage and current ratio. Okay, you can find out the current and current ratio. There also you can check how many zeros and how many poles you're getting. Okay, so that will be your task, IO upon II. So now let's find out the DC gain. DC gain will be simply 0, because I have a 0 at S equals to 0. Now what about the high frequency gain? So high frequency gain also I cannot be able to comment on. Why I will not be able to comment on, I'll just explain in a bit. Okay, where did everything go? Okay, here, right, what will be the high frequency gain? High frequency gain. So basically your high frequency gain is the gain at t equals to 0. Like t equals to 0 means omega infinity, and omega infinity, omega also 0 means t equals to infinity. Like you can interchange those for a simple stable circuit. Now here, right, at infinite frequency, what is happening? At infinite frequency, this is also providing infinite impedance, this is also providing infinite impedance. Again, I can ignore this R. So if I ignore this R, what will happen is that just make this more bigger. This R will be ignored, right? because both of them are providing infinite. Just change the color, infinite and infinite. Okay, so this is at s equals to infinity. So what will happen? Current will simply get divided because it current source is seeing what? Current source is seeing equal impedance on both the branches. So let's say my IO of S will be II, this will be in capitals actually. IO of S will be II of S into L divided by 2L. So, or not L actually. Like what is the impedance that each of these inductors are providing? SL, and this is 2SL, right? So this will be II by 2 simply. So what will be my VO? My VO, right? VO is equals to S SL, like this is the impedance provided by this inductance, times the II, like current, that is II by 2. So VO by II, right, at infinite frequency, or I can write the transfer function h of infinity it should be equals to S L. Okay, so this is my value of A this time. So how will I write my transfer function? Actually my transfer function, right, I won't write the other 0, okay, because 0 at s equals to 0, that will be problematic for me. Why, I will explain. So A into S L by R plus 1 divided by S 2L by R plus 1. Now I will, this 0, right, this 0 is hidden here. So even if I write this 0, okay, let me write this 0, okay, then I will, this is not, then this will not be A anymore. So A can be anything, so you can write A anything, okay. Sorry, this will be SL by 2, right? Okay, so now I will equate this thing with putting infinity over here. So if I put infinity over here, right, if I put infinity over here, what will happen is that, just copy this, like this coefficients, like coefficient of this will remain, this will get eliminated, and this S also will remain. So h of infinity, right, h of infinity will be L by R into S divided by 2L by R. Okay, so what will be my, this, what is this equals to? This is equals to SL by 2, right? So this SL by 2 is automatically getting consumed over here, and my R will be, this RR will get cancelled, like my A will be simply, this SL is also there, A will be simply what? 1. A will be simply 1. Okay, so from this equation A is simply 1. So what is my transfer function? My transfer function H of S is simply SL by 2 into SL by R plus 1, not 2, actually this is simply 1, right, because A is 1. I have just computed from this equation, A is 1. Okay, and this will be S2L by R plus 1. Okay, so this is the transfer function. These are the things that we need to keep in mind in our case. Okay, so can you draw the border plot now? Can you draw the border plot? Obviously you can, right? So if I just copy this and paste it, so a lot of intuition is going on here. I hope you like this portion, because like I have to think a lot to understand intuitively how it works. Obviously you can do mathematical things, Laplace and all, you can solve it in seconds, not seconds, you can solve it in minutes and 30 minutes. Okay, it will take you some 30 minutes to do, but I didn't use Laplace, I used the intuition. So I hope you appreciate those things. Okay, so now here, right, obviously I have a 0 at s equals to 0, so obviously it will start from negative infinity, and as I have a 0 at s equals to 0, the initial slope will be plus 20. Single 0, initial slope will be plus 20. I will just draw this. Initial slope will be plus 20. Then I am getting, like, what is my omega p? Omega p is R by 2L, and omega z2 is simply R by L. So omega Z2 is greater than omega P. So I will encounter a pole first, then I will encounter a 0. So if I encounter a pole, what is the magnitude at this pole? Like if I just compute the magnitude, we can compute the magnitude at R by 12. What is happening? R by 12, this is providing me under root 2, and R by 12, right? R by 12. So this is providing me 1 plus 1 by J2, and this is also R by 12. Okay, so it will depend on the values. Okay, the homework for you is find out what is the magnitude at this pole frequency. Okay, so I will assume that it is somewhat greater than 1. Okay, hence it will stop at somewhat above the x-axis. Okay, somewhat above the x-axis here, right? This is my pole. This is the point where like I encountered the pole. Then obviously the slope will become 0, because 0 was providing me a plus 20 dB per decade, but I encountered a pole, so it will provide me a minus 20 dB per decade. Overall that slope will be 0. Then at omega Z2, right, omega Z2, I'm again encountering a 0, so this will again increase. Okay, this will again increase. So like obviously you might say, sir, how the gain is getting infinity? I told you, right, it is a resistance transfer function, not a simple voltage ratio or a current ratio. That's why it can go to infinity. Okay, so this is providing me plus 20 dB per decade, and this providing me plus 20 dB per decade again, and this is 0 dB per decade. So this is the Bode gain plot. Now what about the Bode phase plot? The Bode phase plot will be again interesting one. Okay, so here what is happening is that omega P is this, omega Z2 is this, right? So initially at s equal to 0 I am getting a 0, so obviously it will start off with 0 phase, sorry, not 0, 90 degrees phase. Then after that what will happen? The frequency, after with increasing frequency, I will encounter either a pole or 0. 10 times before a pole or 10 times before a 0. Which one is coming earlier? Obviously pole will come earlier, because pole is anyways lower than the 0. So I will at first here, right, at here what I will encounter? I will encounter a pole that is what? R by 20L. R by 20L, because 10 times lower than the pole. Then I will encounter the 0, because 0 is just after that is R by 10L. Then I will encounter the actual pole, that is R by 2L. Then the actual 0. Then 10 times more than the actual pole, that is 5 R by L. Then I will encounter 10 R by L. Okay, the 0 actually. So what will be this? So here, right, what is happening? I'm encountering a pole at this, so effect of pole will be taken into factor here. Then just after this R by 10L, right, this is, so we'll just mark these points. This is what? Omega P by 10. So I'm encountering a pole here. Then this is omega Z2 by 10. This is omega P. This is omega Z2, and this is omega 10 omega P2, and this is 10 omega Z2. Sorry, not P2, only single pole, right? So obviously after this point, right, I'm encountering the effect of pole. So pole will be active after this, and after this R by 20L, right, that is the 0, I will encounter the effect of zeros as well. Zeros will provide plus 45 degree per decade, and poles provide minus 45 degree per decade. So overall my slope will be 0. Okay, up until what? Up until this point, right? And after this point, what is happening? The effect of pole is going away. So I was getting minus 45 degree per decade. That effect will go away. So this will become plus 45 degree. Overall slope will be only due to the effect of 0. And then at 10R, right? At 10R, what is happening? The effect of 0 is also going away. Hence, this will be simply plus plus 90. This is stop at plus 90 and end at plus 90. Okay, stop at plus 90 and end at plus 90. So you can obviously say what will be this value. Okay, what will be this value? This will be homework for you. And why will it end at plus 90? Why will it end at plus 90? Because at s tending to infinity, right, this is providing plus 90 degrees, this is providing minus 90 degrees, so overall this will get cancelled. Only this will provide how much? This will provide plus 90 degrees again. This is a constant value. This is providing always plus 90 degrees. Okay, so at the end also it will start from it will end to 90 and it will start from 90. Okay, so yeah, this is the Bode phase plot and the Bode gain plot. I hope you understood this intuitively. Like this slope is how much? This slope is minus 45 degree per decade. This slope is minus 45 degree per decade, and this will be 0 degree per decade. Okay, so all these slope values will be this, and this will be the Bode phase plot. I hope you understood this. Please go through it again to understand intuitively what is happening. Okay, so let's analyze the fifth circuit now. So in the fifth circuit, this is a very interesting circuit because here everything is different and 2 resistors I have, 2 inductors I have. So this whole discussion will be interesting. So please do watch it very carefully. Okay, and watch it in a full, watch it with full concentration. So now, how many number of independent energy storing elements I have? So if this has, right, if this has some, I give this some initial current of what? If I give this some initial current of IL1, then what will be the initial current through this? That will be fixed, right? What will be that current? That will be II minus IL1. Okay, so that is a fixed current. The current through this is fixed. So that means that like only one, I can apply only one independent initial condition and the other one will be fixed. That means only I have one independent energy storing element. Now how do I find out? So first of all, as there is only a single independent energy storing element, so pole will be single. Okay, single pole, and obviously response will be exponential. Okay, response will be exponential. Now next, like how do you find out the dependencies, right? You remove the independent sources and find out, like we have to find out the tau, right? What is tau? Tau is L equivalent upon R equivalent. So for us to find that, obviously we have to remove the independent sources. Here, what is the independent source? Independent source is this current source. That will be open circuited. So if there is some, like now if there is some current I flowing through this, right? I flowing through this loop. Okay, that will also flow through this. Hence, the same amount of current I is flowing through this as well. So when the same amount of current flows through two elements, they are in series, same applies for this R1 as well. So basically what will be my L equivalent and R equivalent? It will be simply L1 plus L2 divided by R1 plus R2, and I will solve it with two difference because I will derive totally this, right? I will solve it all the different, like L1 L2 is not equal to some common value L, and R1 R2 is not equal to some common value R, so that you can apply all this, right, in all the previous analysis. If let's say the values were different, then you just make one of them 0. So in this previous circuit, right, I had only a single resistor, so you make this R2 here 0, and you will be able to solve, like just you, like whatever equations I will write, whatever plots I will do here, right, just make R1, sorry, not R2, R1 0, and you can derive for different values of L1 and L2 and for the further circuits as well. That's why I am doing this completely. Okay, and the discussion will be really interesting here. So like order we have already found out, so I will delete this page. Let's start with the intuition of unit step response. So in unit step, what is happening? I'm applying a 1 amps of current through this. So both the inductors, what initially they have no charge, they have no energy, no flux, hence both of them will try to keep that same energy, hence no current will flow. Okay, they will be open circuit, but as they're providing very high impedance, right, this resistor I can ignore, and this 1 amp current has to flow through the inductors. That means that current, like this 1 amp current has to flow somewhere, anywhere, right? Even though there is infinite impedance, this current source will try to flow 1 amp of current. So what will happen is that it will apply impulse voltage across both of these inductors, and both of them will get instantly energized to this current, right? And what will be the value of the current? The value of the current will be depending on their inductances. I will talk about it just in a bit. What will be the value of the current? Okay, so Next is because the impedances that they provide, that will give us that will derive the expression for the current of current across the second inductance and the current across the first inductance. Okay, so flux will across the inductors will increase. Then what will happen? Then this will be always constant current, right? This will be always constant current, and at steady state this will be short circuit and this will be short circuit, because the rate of change of currents will be zero through them. So R1 and R2 will come in parallel, and then the current division will be according to R1 and R2. So initially the current division was according to L1 and L2, and finally the current division will be according to R1 and R2, and in between many things are happening, energizing and de-energizing. Whether this inductor will get energized or this inductor will get energized will depend on the value of L1, L2, R1, R2. Okay, all those things will depend. So this is the intuition, and in between, right, response will be exponential. In between, response will be exponential. Okay, so that is the thing. Now I will just do the analysis part here. So initially, inductor has no flux. L has no flux. Okay, that means what? That means my psi of 0 minus is equals to 0 is equals to Li of 0 minus for both the cases. Okay, for both the inductors. But at t equals to 0, what is happening? Or t equals to 0 plus, what is happening? Like this R I can ignore, right? Because this impedances, this inductors will provide very high impedances, right? This inductors will provide very high impedance. What will be the value of the like impedance? This will be SL, and this will be also SL, right? Like in frequency domain, SL1 and SL2. SL1 and SL2. Okay. So what is the value of the inductances? So like what is the value of the current? So current, right? This current is IL1 of 0 plus, and this current is IL2 of 0 plus. So here what is happening is that my current let's say IL2, right? IL2 of 0 plus will be simply what? This is 1 ampere, right? This has been replaced with 1 amperes. This is at t equals to 0 plus. So this will be what? L1, like this will be the opposite impedance, right? Opposite impedance SL1. The current division happens like this, right? I take the opposite impedance, then sum both the impedances, SL1 plus SL2. Okay, into obviously the current, that is 1. So what will be my IL of 0 plus? IL of 0 plus will be simply IL2 of 0 plus will be simply L1 divided by L1 plus L2. L1 divided by L1 plus L2. Okay, so this will be my current across the second inductor. And what will be IL1? What will be IL1? So IL1, right? IL1 will be L2, but I will not analyze it because you will be able to easily analyze it. Basically, my after this, right? After t equal to 0 plus, my IL1 plus IL2 will always be equals to 1. So if I know IL2, then I will be able to find IL1. I'll just not waste my time. And at t equals to infinity, what is happening? At t equals to infinity, okay, I will just draw the same circuit. Just copy this again. This is reaching steady state, right? So hence at steady state, the dIL by dt, right? dIL by dt will be 0 because as inductor has reached steady state, it will not change its current, okay, because it will try to remain at the same state. Hence my voltage across the inductors will be 0 at infinity. 0 volts at steady state. This is at t equals to infinity. So this will be short circuited. Okay, and this will be short circuited. Hence, what will happen here? Basically, the current, right? This is 1 amperes. Just hold on. One amperes. So how will the current division work? So current will be divided like this. So IL2. So I will just mark the currents over here. This is, have I marked it correctly over here? Yeah, I marked it correctly. This is IL1, not IL1, sorry, IL2 of infinity. and this is IL1 of infinity. Okay. So what will be my IL2 of infinity this time? Again, like it will be opposite impedance R1 divided by R1 plus R2. Okay, into 1 ampere current is flowing. So IL2 infinity will be R1 divided by R1 plus R2. Okay, this will be my IL2, and like you can find out from this what will be my IL1, and this IL2 is basically equals to my IL0 infinity. What is V of 0? So VL of infinity is this. So V of 0 infinity will be what? Simply this drop, right? This drop. What is this drop? This is basically this current into R2. So this will be R1 into R2 divided by R1 plus R2. And what about this drop? What is happening here, right? A step current is flowing. A step current is like instantly this inductor is getting energized to this step current, right? Previously the current was 0. So what will happen? Basically an impulse will get applied. Like I've derived how this impulse will come in previous examples. So my VL2 will be equals to my VL2 of 0 plus VL2 of, or not 0, 0 equals to V of 0 plus, this will be equals to what? This will be a impulse of amplitude what? L di dt, right? This will be L2 L1 by L1 plus L2, okay, of delta t, L di dt. That's why this is happening. So I'll just reduce the size of these things. That will be much more simpler. Yeah. So this will be my V of 0 plus, and this will be not 0 plus, sorry, this V of 0. And at 0 plus everything is getting changed. Okay. So yeah, this is how everything will work. The inductors will energize or de-energize will depend. So there will be three cases where the case one is what? Case 1 is where my time constant of the input is greater than the time constant of the output. What do you mean by that? So let's say this is the input circuitry. This is the input circuitry due to the source, and this is the output circuitry. That's from where I'm getting this output and input. So in the first case, right, my L1 by R1 is greater than L2 by R2. Then what will happen? Then basically I can write my IO of 0 plus, right? This is my IO of 0 plus. IL2 is also equals to my, let's write this few things here, okay, to make it more tidy. This is my IO of 0 plus, right? So my IO of 0 plus is L1 divided by L1 plus L2. Now can I write this in a better manner? Yes, I can write this in a better manner. Just hold on. What can I do is, this will be L1 divided by L2 divided by 1 plus, I can divide by L2 on both sides, okay, not L2, sorry, I will divide by L1 on both sides, because this I need to make 1, okay. If I divide by L1 on both sides, this will be 1 plus L2 by L1, okay. And what about I of infinity? IO of infinity, what is IO of infinity? So IO of infinity is equals to R1 divided by R1 plus R2 . So this will be 1 divided by 1 plus R2 by R1. Okay, so what is the important thing over here? Like if I do this, right, if I just resolve this here, this will be L1 by, not L1, I will just replace this with L2 by, so R2 by R1 is greater than L2 by L1. So L2 by L1 is lower. So this is lower, right? This is lower. This is lower than this. This is high, right? So obviously denominator is high in this I of infinity, and numerator, denominator is lower in the 0 plus case. So obviously IO of, like what I can deduce is IO of 0 plus will be greater than IO of infinity. Okay, so what will be the plot for this? So obviously in between IO of 0 plus is more, right? So it will start off with higher value, then it will decay down to lower value, and that will be some constant value. That is, what is this? This is R1 upon R1 plus R2, and this is L1 upon L1 plus L2. Okay. Why is this higher? Because I of 0 plus is higher. Why? Because due to the case 1. Due to the case 1 is where my time constant of input is higher than the time constant of output. Okay. This is the case 1. And what will be the equation? Equation will be very simple. Like you can write down the equation. IO of t will be simply IO of infinity plus IO of, so we'll just write this in small letters, IO of infinity plus IO of 0 minus IO of infinity into e raised to power minus t upon tau. Tau I have computed, everything I have computed here, right? Every single thing is computed. I of infinity is computed, I of 0 is computed, and response will be exponential because this is a first order circuit. So case 2 will be similar. Okay, I'll just copy and paste, but other way around. So this time what will happen is that my input time constant will be lower than the output time constant. My input time constant will be lower than the output time constant. Then what will happen? This R2 by R1 will be less than L2 by L1. Hence, this will be more this time. L2 by L1 will be greater than R2 by R1. Hence, this time IO of 0 infinity will be higher and IO of infinity will be higher and IO of 0 plus will be lower. So this will just get flipped. So again, diagram will be pretty simple this time, right? It will energize like that. This L, what was happening here? What was happening? The L2 was de-energizing. Okay. How can I say? Because initially it had this current and finally it has this current, lower amount of current, right? So final minus initial energy, that is negative. So obviously inductor is de-energizing. Okay. And in this case, the L2 inductor, right, is charging. So not charging, energizing. L2 inductor is energizing. So this will be, the values will be same, L1 by L1 plus L2, not L1 plus, this will be in the bottom case 0, and this will be R1 divided by R1 plus R2. Okay, so this time it is energizing, right? Why? Because the initial current is lower and the final current is lower. So final energy minus initial energy is some positive value. So obviously this will, I can say L2 is energizing. Okay, and like what will be the expression of the current? Expression of the current will be remaining the same, this only. Okay, expression of the current will be this only. Now what about the third case? In the third case, right, the interesting thing will be if the input and output time constant are equal to each other. If the input and output time constant are equal, then what will happen? Then L1 by R1 will be equals R2 by R1 equals to L2 by L1. So this will be equals to 0 plus and IO 0 by infinity. So obviously everything will be equal here. These two will be equal, right? These two will be same. Why? Because the denominator is same, numerator is same, right? Denominator L2 by L1 is equals to R2 by R1. So denominator is same for this and numerator is same, that is 1. So obviously IO of 0 plus will be equals to I of infinity. That means what? That means it is instantly getting energized and it is not changing its state. What is happening in this case? What is actually happening intuitively, right? There is pole zero cancellation. Pole zero cancellation is happening. And due to that, the pole and zero are getting cancelled and the response, right, is like a zero ordered circuit. Response is like this. Okay, zero ordered circuit. This is a step current, that is L1 by L1 plus L2 will be equals to R1 by R1 plus R2. Both of these are equal. Okay, so this will act like a first order circuit, that is IO of t will be equal simply IO of 0, that is L1 by L1 plus L2, that is unit step, equals to R1 by R1 plus R2. E of t, in this case, right, what is happening? The time constant is 0 because there is no settling at all. It is settling instantly. Okay, so these are the plots for the current. Now, like, can you, like, the homework for you is plotting the voltage, plotting the output voltage. How will you plot the output voltage? Just what you need to do is just first of all draw the current expression for this and then plot it. Now let's derive the poles and zeros and draw the Bode plot for this. So what are the poles? Poles is again the same thing, right? Poles is again the same thing, that SP, like this will be a single pole circuit only, will be equals to 1 by negative inverse of time constant, right? So like negative inverse of time constant, that is in our case it will be minus of R1 plus R2 divided by L1 plus L2. This will be my time constant. Okay, or what you can do, you can try to make infinite impedance over here. This will be negative of this, and from there you will be able to find the pole. Okay, how will you do this? So here I want to make negative impedance, right? I want to make negative impedance. So obviously my SL1 plus R1 should be negative of SL2 plus R2, and from there, right, if you derive this, this will be S, I will take common, L1 plus L2 will be equals to minus of R1 plus R2, and from here you will be able to find out the pole as well. SP will be equals to minus R1 plus R2. If you are not understanding how am I doing this, you have to go back and watch my realizing poles and zeros intuitively. Okay, so yeah, what are the zeros? So zeros, right, what you can do, either you can short the output or short the input. So here, right, both things are possible. So there are two zeros in this case, and that is possible because again I explained this is a resistance transfer function, so zeros can be more than poles. So first I will try to short the output. So obviously this will be R2 plus SL2 equals to 0, or like you can write that SL2 equals to minus R2, that also you can directly write. So your SZ1 will be equals to minus of R2 by L2. And what about SZ2? SZ2 will be equals to minus of R1 by L1. Basically what you are doing, you are shorting the input this time. So we'll just reduce the size. Short the input. Minus R1 by L1, right? So this will happen because I'm making zero impedance here and zero impedance here. Okay, so these are the zeros, these are the poles. Now what is the DC gain? DC gain will be at S equals to 0. At S equal to 0, what is happening? At S equal to 0, this is giving zero impedance, this is giving zero impedance, so I can basically short it. Okay, I can replace with this, like this inductor with short circuit. Okay, and short circuit. So basically my VO will be what? Like what is this current? IO will be, can write in Laplace, IO of infinity will be basically R1 by R1 plus R2 into I of infinity, I of infinity. And what is VO of infinity? VO of infinity, this is in Laplace, right? S equals to infinity, this is not time domain, so this will be R1 R2. Just hold on, I will check if everything is recording and fine. Yeah, everything is recording and fine. R1 R2 divided by R1 plus R2. Okay, this divided by, obviously I have to divide it by II as well. Okay, this is equals to my A. Okay, this is equals to my A. And what about okay, I was sorry, this is not high frequency, sorry, this is DC gain, right? So this is DC gain, this is DC gain. So we have 0 0 and 0. So this is my A. A is the DC gain this time. What about the high frequency gain? What is happening at the high frequency? At high frequency, right, this will behave as open circuit, this will behave as open circuit, hence this resistor I can ignore. So what happens now is that the inductors come in parallel with each other. Inductors come in parallel with each other. So basically here, right, this is my H of 0, this is my H of 0, and this is my H of infinity. So H of infinity, what is happening? Basically I will compute the H of infinity later on. First of all I will compute the IO of infinity. Again there will be voltage division, right? This will be SL1 divided by SL1 plus SL2 into II of infinity. Okay, so VO of infinity will be equals to what? IO of infinity into this SL2, right? IO of infinity into SL2, like not so what is this IO of infinity? It is L1 by L1 plus L2 into SL2, right? Into SL2. So H of infinity will be simply high frequency will be SL1 L2 divided by L1 plus L2. Okay, just hold on. L1 plus L2. Okay, this is my high frequency. So like, what is my transfer function? If you want to write your transfer function, right, you can simply write your transfer function, that your transfer function will be H of S A into S this 0, right, S by omega Z1 plus 1 into S by omega Z2 plus 1 divided by S by omega P plus 1. There is only a single pole. So if I replace everything over here, right, so H of S is, what is my omega Z1? Omega Z1 is, like, I will write the values over here. Omega Z1 is R1 by L1. Omega Z2 is R2 by L2. Omega P is simply that negative of time constant. Omega P is R1 plus R2 divided by L1 plus L2. Okay, so my H of S will be what? H of S will be what? H of S will be A. What is A? A is this, right? R1 R2 divided by R1 plus R2. Okay, A is this. So just hold on. R1 R2 divided by R1 plus R2 S upon omega Z1. So this will be simply SL1 by R1 plus 1, then into SL2 by R2 plus 1 divided by S into L1 plus L2 divided by R1 plus R2. Okay, plus 1. So this will be totally the equation. This will be totally the equation, right? This will be totally the transfer function. Okay, I know this is a mess, this is a big transfer function, but this will be the transfer function, right? Because all the values are different, that's why, like, when this L1 by R1 will be equals to L2 by R2, right, what will happen is that like, this will give me single pole and there will be pole zero cancellation, so only single this will remain, and that's why, like, it is like instantly settling. Okay, so this will be the transfer function for VO over II. Okay, so I will just name this transfer function differently because I won't plot the border plot for this. Border plot will be different for this, and computing the border plot exactly for 3 cases will be different. I will plot what? I will plot the current transfer function this time. So this, right, this is the border plot for T of S. T of S is what? T of S, I will define T of S as this. Okay, T of S will be defined like this. Okay, which is equals to my VO of S divided by I of S. But what am I really interested in, and in the interview what they can ask is, that is why I'm changing this question a bit. So here, right, this will be basically like here, right, this is for the voltage, but for the current as well, what will happen? Current, for current, right, zeros will change a bit. So for current, if this goes to 0, then all the current will flow through this. Okay, so no current will flow through this, so this current will be 0. So for current as well, for current, if my, like, how do I make, I am now, what I am interested in is current transfer function, that is h of s. This time h of s, I'm just changing the question a bit. H of s equals to IO of s divided by II of s. Okay, why am I doing this? Because in the interview they can ask this as well. So I'm trying to cover everything. What they can ask in the interview. Okay, so IO of s divided by II of s. So here what will happen is that this is for that voltage transfer function. Okay, voltage upon current. Now if I short the output, right, if I short the output, what will happen? All the current will flow through this. So IO will be totally equals to II. So IO will be totally equals to II. So we won't get a 0 over here. So shorting the output won't give me a 0. So what I will do is I will just write the poles and zeros for this transfer function is, okay, just hold on. For this transfer function I'm writing the poles and 0 for this, right? For VO of s over IO of s, II of s for this case. Now what I will do, I will just copy this and derive the transfer function for like IO of s divided by II of s, because I have just done the analysis for IO over II, right? That's why. So I'll do that only. So here in this case, what is happening is that this IO of s over II of s, pole will remain same. So pole will be same, like it will be negative inverse of time constant. Now what about the zeros? So if I short the output, right, all of the current is flowing through this. So what do I need to do? I need to short the input. If I short the input, sorry, I told you wrong. If I short the output, right, all of the current will flow through this. So that means no current will flow through here. Okay, no current will flow through here. That is, this current will be 0, this current will be total II. So if I short the output, then my IO of s equals to II of s. So that is not much useful to us because it is not going to get 0. If I short the input, right, what will happen is that all of the current will flow through here through the input circuit, and none of the current will flow through the output. Okay, I am shorting the input this time. So all of the current will flow through the input and none of the current will flow through the output, right? So this time, right, if I short the input, my IO of s will be 0. That means that I have a 0 at minus R1 by L1. Okay, so what about the DC again? So at DC, right, what is happening? What is the current? Like I've already computed here, it will be simpler. Current will be simply IO of 0 divided by II of 0. Okay, so it will be R1 divided by R1 plus R2. Okay, so this is simple. Now what about infinite frequency? At infinite frequency, again, this will be divided by inductance. So at infinite frequency, H of infinity will be equals to L1 divided by L1 plus L2. Basically, this is the ratio of IO of infinity divided by II of infinity, and this is also equals to my A, right? This also equals to my A. So how will I write the transfer function? Transfer function will be written like this. So I have only one 0 this time. So if I have only one 0 and one pole, so you can see, right, for simple voltage and current ratio, the number of poles and number of zeros, like number of zeros can be either equal or less than that. But for other type of transfer functions, number of zeros can be more than that as well. Okay, so omega z1 will be R1 by L1 only because I am shorting the input, and omega p is this. Okay, what will be my transfer function? So A is R1 divided by R1 plus R2 at DC again, yeah, and omega z1 is this, and this is this. So this will be IO over Vs. This is my transfer function H of s. So T of s was different, H of s was different. Why am I doing this? You will understand, because this is a good analysis and this can be asked. So I am trying to cover all bases here. I have covered the resistance transfer function, that is trans resistance, and now I am covering the like current gain, right? Current gain. So these are the equations. And to do a quick sanity check, what you can do, you can find out here, put here s equals to infinity, s equal to 0. If I put s equal to 0, this will go away, this will go away, this will be simple r1 by r1 plus r2. If I put s equals to infinity, coefficients of this will remain, that is l1 divided by r1. So r1 will get cancelled, this will be l1 divided by r1 plus r2 will get cancelled, l1 divided by l1 plus l2, which is correct again. Because at infinity I am getting this gain. So now things will become simpler here. Now I can divide it by case, because if I would have solved it for trans resistance, I wouldn't have been able to divide it by case. So how will I do it? So I'll just copy the previous analysis, right, where I performed case by case analysis for the output current. That I will copy. Okay, this I will copy. So here, right, first case is L1 by R1 is greater than L2 by R2. So everything will be flipped here. Everything will be flipped here basically. So this thing, right, this thing I will cut. This thing will go above, and this thing I will paste here. This will be simply H of infinity. Okay, so h of 0 I know is r1 divided by r1 plus r2. H of infinity this right. So I first case r2 by r1 is greater than l2 by l1. So obviously this will be greater, this will be lower. So hence what I can deduce from this is that h of 0 will be lower than h of infinity. Okay, so everything will be flipped over here. H of infinity will be greater than h of 0. So how will the Bode plot look like? How will the Bode plot look like? So the Bode plot, right, will look something like this. At high frequency I have more gain, at low frequency I have lesser gain. And where will I stop? So here, right, if you see, is that this is a fraction, right? This is a fraction. This will be always less than, because this will be 1 plus something. So numerator is 1 and this is 1 plus something. So this overall thing, right, h of 0 will always be less than 1. Okay, h of 0 will always be less than 1, and my h of infinity will also be always less than 1. So anyways I will lie somewhere around this region, right? I will never come to this region. Why? Because this is a region where my transfer function has positive, like more than 1 magnitude, and if I convert it into DC scale, it is positive in dBs, right? But I will always lie in this because the magnitude is always less than 1. Okay, so like what are the omega p and omega z's? I have already told you omega p and omega z are this. So I will just write here quickly the transfer function. So I'll just copy this. Okay, copy this. Quickly write the transfer function. So what is happening over here is that, how can you say that what will come first? Pole will come first or 0 will come first? How can you derive that? So here, right, what is this is case 1. Case 1 is what? Case 1 is h of infinity is greater than h of 0. Okay, h of infinity is greater than h of 0. So that means if h of 0 is started from here, let's say h of 0 has started from here, then h of infinity should lie somewhere around here. It should be below the 0 dB axis, but still it should lie somewhere around here. So obviously Bode plot is a linear plot, so it will be something straight line joining like this. Hence, which one comes first? Can you pause the video and tell me, will this pole come first or this 0 come first? Here, right, initially I had no slope, then I had a positive 20 dB per decade slope, as like either pole and 0 can come, either I can get plus 20 dB per decade or minus 20 dB per decade. So here, as I am getting some positive slope, that means I am getting a plus 20 dB per decade, that is omega z. I am getting omega z. So this is not z1 actually. Oh, I can write this as z1 as well, omega z1. Okay, I am getting z1. Now here, right, I am encountering the pole, hence my slope is going to 0 again. So in this region, my slope is plus, not plus, this is 0 dB per decade. Then this is plus 20 dB per decade, and this is 0 dB per decade again. So I'm encountering a pole again. So overall slope becomes overall 0 again. So this is the Bode plot for this. And like Bode phase plot, you can do, but like from this what can I deduce here is that from the plot I can deduce that my omega z1 will be lower than omega p. Okay, omega z1 will be lower than omega p. And how will your Bode phase plot look? So I will just do this real quick, that omega p is higher than omega z, right? So how it will look? Roughly it will look something like this. First I will encounter a 0. Okay, hence my slope will be something positive. Then I will encounter the effect of pole as well. So the overall slope will become 0. And then again the effect of 0 will go away. So overall the effect of pole will remain. I will get a negative slope. Okay. So this will be the simply diagram of this is omega z1 by 10. This is the point where I am encountering the pole omega p by 10. And somewhere in between I will encounter the 0 again, omega z and omega p. And 10 times after this, right, I will encounter the 0 first. Okay, this will be 10 omega z. And this will be 10 omega p. Okay, so this will be the Bode phase plot for this. So like I hope you have understood how am I doing this. So for the case 2 and case 3, it will be just be similar. Okay, I'll just copy this thing here. Things will get flipped here, just case 2 and case 3 will be quicker. So for case 2 and case 3, right, okay, case 2 and case 3, so this I will copy and paste. So for case 2, this will be opposite, as this is opposite, right? Just hold on. As this is opposite, what does this mean? This means that this time these will be opposite, right? My L1 by R1 is less than L2 by R2. That means my L2 by R2 by R1 is less than my L2 by R1. So this will be lower, this will be higher. That means this will be low, this will be high. So my h of 0 will be high and h of infinity will be less. That means what? That means if my h of infinity, I'll just copy this again. Okay, just copy this whole thing. If my h of infinity is lower than h of 0, that means I will first get the effect of pole, then the 0. Why? Because h of infinity is low, right? So I will stop somewhere around here at infinity. I will start somewhere around here because h of infinity is lower. So obviously to connect these two, I need to go in the negative slope, right? Negative slope. Hence I will encounter a pole first, then I will encounter a 0. Encounter a 0. So this will be what? This will be h of 0 and this will be, okay, this will be 20 log h of 0, right? 20 log h of 0. Just write here 20 log h of 0 and this will be 20 log h of infinity. Okay, so the phase plot will be what? Phase plot will be now overall negative. Why? Because initially I will get the effect of pole, not 0. I will get the effect of pole. Hence, why? Because my pole is less than omega z1. That's why I will get the effect of pole initially. Then the effect of 0 will come. And then the effect of pole will go away. Hence, I will get a positive slope. And then again, the effect of 0 will also go away. So this point is what? This point is basically omega p by 10. This point is what? This point is basically omega z1 by 10. This point will be somewhere omega p. This point will be somewhat omega z1. This point will be 10 omega p and this point will be 10 omega z1. Effect of 0 will go away. So this, what is this slope? What is this slope? This slope is like, this is 0 degree per decade. This is minus 45 degree per decade. This is 0 degree per decade. Okay, this will be plus 45 degree per decade. Why? Because the effect of 0 is still remaining, the effect of pole has gone away because pole was lower than the 0. Okay, so what is the third case? Third case will be much more simpler. So in the third case, right, in the third case, just copy here everything. Everything will be equal, right? If everything is equal, then things will be much more simpler. Okay, so you just copy this. So obviously this is equal, this is equal, this is equal. If this is equal, that means both of them are equal, both of them are same. Okay, if both of them are same, then h of 0 also is same. Okay, h of 0, h of infinity is also same, hence h of infinity is equals to h of 0. That means I'm getting a pole and 0 at the same place. Basically there is a pole 0 cancellation. There is a pole 0 cancellation. Okay, there is a pole 0 cancellation. That means what? That means that it will be something negative. Obviously it will be something negative, and it will be a straight line because I'm encountering pole and 0 at the same point. Obviously the slopes will get cancelled, and this point will be h of 0, like 20 log h of 0 equals to 20 log h of infinity. Correct? So this will be Bode plot, Bode gain plot as h of 0 is equals to h of infinity. And here, right, there will be no phase change because there is a pole 0 cancellation. So phase will be simply 0. Okay, I will not get any phase because my h of 0 is equals to h of infinity. Wherever I am encountering a pole, I am encountering a 0 as well. So pole 0 cancellation, pole 0 cancellation. Okay, so yeah, this was it about this question. So this is a very good question. Please do revise it because this is a very good analysis, and this is the highest level that any interviewer can go to. Trust me, in RL circuits and like in RC as well. I have covered the highest level. Don't worry, if you are able to understand this, they won't be able to ask anything outside of this. They will ask anything inside this, but nothing outside. So I have tried to cover every possible thing that can be asked. Let's start the sixth one, right? Sixth one is pretty simple. I have two inductors in parallel with each other, and I have to find out the voltage and current, right? So first of all, what is the order of the circuit? Can you reveal the order of the circuit? So according to the voltage, right? According to the voltage, what is the order? So here, right, if I assume both of them to be same, or even if I don't assume both of them to be same, if I assume L1 and L2 to be different, then can I directly make a transfer function here? My IO will be what? My IO of S by II of S will be equals to what? Will be equals to simply L1 divided by L1 plus L2. Okay, and this is a constant. This is a constant. This is a constant. Now what about VO by II? What about the trans resistance? So this was a current gain. What about the trans resistance? So the trans resistance, right? The IO is what? IO is VO by SL, right? IO is VO by SL. So it is VO by SL1. SL not 1, SL2 into II. Okay, II of S equals to L1 divided by L1 plus L2. So obviously, if an inductor is in parallel and it is a zero order circuit, then obviously if I compute the voltage, right, it will add a 0 to it. Like you can watch my video realizing poles and 0 intuitively. It is on the playlist of analog electronics decoded. Okay, so you can go over there and watch that realizing poles are zeros intuitively, the latest video. Okay, there I have told about this concept. So here what will happen is that VO of S divided by II of S will be equals to S L1 L2 divided by L1 plus L2. Okay, so VO of S divided by II of S will be this. Now what about we have computed everything. So if if L1 equals to L2 equals to L, then my current transfer function, right, current gain AI equals to, I should not write this because this few people will get confused, that is IO of S divided by II of S will be equals to simply 1 by 2. Okay, it will always be 1 by 2 constant, and my VO of S divided by II of S will be equals to what? Will be equals to SL, SL1, L2. So both will be equal. It will be SL by 2, right? It will be SL by 2. Am I correct here? Yeah, LL cancel. Yeah, SL by 2, right? It will be SL by 2. So this will be my trans resistance and trans current gain. Okay, so like let's do the unit step response. Impulse response I want to, like, it will be just same as unit step response. So what will happen? Initially 1 ampere of current will come, right? Initially 1 ampere of current will come and it will try to flow, and both the inductors will be open circuit. And if both the inductors are open circuit, but current source will pass this 1 ampere of current source will pass this 1 ampere of current anyhow current source will pass this 1 ampere of current, right? Anyhow, it doesn't care about anything. Okay, so obviously if both are equal, right, if both are L in this case, so it will be half only. Half amperes of current will flow, and it will remain at that half because it will be stable, right? It will reach steady state because it will be constant. After that, there is no like voltage change and all those things, so it will remain constant because inductor doesn't try to change its state, and half is its steady state, hence it will never change. So IO of 0 plus will be equals to half, and IO of infinity also will be equals to half only, because at steady state what will happen? It will become short circuit, right? Just draw the things. Okay, just hold on 1 second. This sound, I need to turn it off a bit. Yeah, steady state this will be short circuit, and again half ampere of current will flow, which is satisfied because transfer function is what? Transfer function is 1 by 2. So if II is 1, it will be IO will be 1 by 2. Simple as that. Okay, flux changes instantaneously here. So in this case, right, initial my IO 0 minus was 0 amperes. Okay, so this became half amperes at 0 plus, like 0 plus time, no time. So here what is happening? Just hold on. Yeah, this is correct only. Flux is changing instantaneously. I was just checking one thing. Flux is changing instantaneously. Okay, so flux changes instantaneously. What does that mean? That means like a impulse voltage is getting applied across the inductor. So VL of 0 will be what? It will be simply delta by 2. Okay, delta, and L will obviously be there, delta into L by 2. Okay, that will be the amount of flux that that will be the amount of voltage that needs to be supplied by the current source so that the inductor changes its voltage instantaneously. Okay, and at steady state what will happen? VL of infinity will be 0 volts. Okay, so like let's draw the plots. Like I have taken a very short amount of time because this doesn't need much explanation here. So how will the current look like? Current will instantly follow the input by 2, so it will instantly go to 1 by 2. It will be like a step. Okay, so IO of t will be 1 by 2 yacht. Okay, and VO of t will be what? V of t will be simply impulse. Okay, V of t will be simply impulse. Okay, so it is delta t into L by 2. Impulse of area L by 2. So L by 2 will be present over here. And what is next? Like this is the next thing only, because we want like study the impulse response. Impulse response is also very simple. What will happen? Impulse current half area will come across this inductor, and what will happen? Output voltage will be what? It will be a doublet function. Okay, the differentiation of impulse basically. So nothing to stress about here. Like what will be the transfer function? So transfer function will be simple, right? Pole zeros we don't need to take care of. For resistance transfer function, it will be simply VO by II of S. So I know what is my poles and zero. It is simply SL by 2. If L1 is equals to L2, right? Okay, if L1 is equals to L2, so like don't need all this space because everything has been computed already. So what will the Bode gain plot? Bode gain plot, right? This is SL by 2, right? So I have a 0 at S equals to 0, right? S equals to 0, I have a 0. That means it will start from some negative value and it will always keep on increasing. Always keep on increasing, okay? So this will be my like Bode gain plot, okay? And this slope will be plus 20 dB per decade. Okay, this slope will be plus 20 dB per decade, and obviously at S equal to 0 I'm providing a 0. The transfer function is providing me with a 0. That means that at that instant itself it will be plus 90. At that instant itself it will be plus 90. Okay, and it will remain at that. Okay, so these are the things that you need to take care of. Okay, like my transfer function is SL by 2 simply, nothing much to worry about. But in the current gain stage, what will happen? Transfer function is IO over II. So H of S this time, right? H of S will be what? It will be simply half. You can do the voltage divided, it will be simply half. So again, this is also very simple, nothing much to rave about here. So this will be always constant, that, and it will be in the negative, right? Negative side, because this will be minus 20 log 2 because like half is a number that is less than 1. So H of S is 1 by 2. Okay, next, what about the angle? Angle will be simply 0 because half doesn't have any phase with it, so it will be simply 0. It will always remain at 0. Okay, so this was it about this circuit. Very simple analysis. Now let's move on to the next circuit. So let's solve this next circuit. So this next circuit, this circuit looks very interesting, right? I have two inductors and a current source, like this R is there. So something like, it seems like something will happen, but in all honesty, like nothing will happen. Now from here on, right, whatever we'll solve, literally nothing will happen. Everything will be same, just like the previous circuit. Okay, why? Because whenever a current source is given, right, and if I just write a simple KCL equations, let's say the KCL, like the current through this resistor is I1, okay, and current through this inductor is I2. So what is the first KCL equation I can write? I can write that II equals to I1 plus I2. Okay, this is the first KCL equation. What is the next KCL equation? Next KCL equation is this, right? This is my IO. Okay, and like here no current is flowing. This is open ended, right? This is open ended. So what is my IO? IO is also I1 plus I2. Okay, so basically, right, this particular section is redundant, right, for a current source. Whenever a current source is present, this section is redundant. Okay, this has no use. There's no use for computing the output, like for computing VO and IO. I'm only talking with respect to this particular section, that if I want to compute the voltage and current of this particular inductor, then this circuit has no use. Okay, this circuit has no use. This LNR has no use. What I can do is I can directly connect this across the current source. Hence, what will be the order? Order here will be 0, because if I find the current gain, right, basically my IO is equals to IO equals to I. Just hold on a sec. Let me just do one thing. This is better actually, or not. Let me take a deeper color. I'm trying to find a deeper color actually, and I'm not able to. That is a problematic thing. Yeah, this is fine. So in this case, right, my IO is equals to II. So my current gain will be what? Capital IO of S will be equals to II of S. Okay, this will be equals to 1. This will be equals to 1, right? So IO of S divided by II of S will be equals to 1. Now, what can I say? Nothing to say, right? What is the voltage transfer function? It will be same, right? It will be same. It will be VO of S divided by II of S. So it will be simply equals to what? Like IO I can write as what? VO by SL, and SL can go at the right hand side. So this will be simply S and L, right? This will be simply S and L and nothing else will happen. Okay. So this is the current gain and this is the resistance transfer function. So like don't need to go with the independent energy storing element because that middle circuit is not of much use here. Okay. Like from here also you can understand that if this current is this, if this inductor has some initial current, right, then this current is fixed because this is fixed and this has been fixed. So this current is fixed, right? That's why only one independent energy storing element present over here, right? So, but the thing that you have to understand is like it is directly connected across the current source. That's why order is this is a zero order circuit. Okay. So here initial and final conditions simple, right? A current source is directly connected in series with the inductor. So what will happen if initially like there was no current? So initially flux was 0. Okay, initially flux was 0, phi of 0 minus, but what will happen? So my IL of 0 minus will be 0. But what is my IL of 0 plus? Because IL of 0 plus, right, if the circuit will look something like this, IL of 0 plus circuit will look something like this. Thus this is 1 ampere of current directly in series with the inductor. So obviously 1 ampere of current will flow. So current source like this IL of 0 plus will be 1 ampere and it will settle at that point. It will settle. So obviously a impulse voltage has to be applied across the inductor. What will be the value of the impulse voltage? It will be simply L delta of t. Okay, that will get applied, and after that, right, VL of 0 plus will be 0 and it will remain at 0 because it will instantly settle. It will instantly settle after that. Okay. It will instantly settle. So obviously my VL of 0 plus, and this is at steady state, right? This is at steady state. That is t is equals to infinity. And 0 plus also it will instantly settle. So what will be the plots? It will just follow the input, right? It will just follow the input current. So input current is a step, unit step. So output current also will be a unit step. Nothing to glorify here. And the voltage initially I will get an impulse like at t equals to 0 I will get an impulse of magnitude L, and then obviously it will remain at 0. Okay, it will settle instantly. So this will be what will happen. And what is resistance transfer function? So I will just copy this circuit. Okay, if I just copy this circuit, we have just computed the resistance transfer function. It is simple only. It is basically equals to what? My VO over VO of S divided by I of S equals to simply SL, right? Simply SL. It is simply SL, nothing else to like glorify. So what will be my border plot? Border plot, I have a 0 at S equals to 0. So obviously this will start like this, and this will be plus 20 dB per decade, just like previous case. And what will be my phase plot? Phase plot will be plus 90. It will remain at that because at S equal to 0 I am getting a 0. So I will get a plus 90 degrees. Okay, so this is the border phase plot. Now what next? Like the current transfer function, right? Current transfer function. What is the current transfer function? Current transfer function again is pretty simple. Simply IO is equals to II. So IO of S divided by II of S equals to H of S equals to 1. So it is 1. So obviously my Bode gain plot will look like something this. Bode gain plot will be just 0 dB, right? Because gain of 1 means 0 in dB scale. Then what about the Bode phase plot? So Bode phase plot, right? Bode phase plot will be simply 0 because it is a constant value and it doesn't have any frequency component, so it will be simply 0. Okay, phase plot also won't change. So now let's come to the next circuit. So this circuit is also like same only because here I have replaced L with R, so this is even simpler. Okay, so like the things will be same again. Like here I will prove that my this is redundant. Okay, this is redundant element, right? Just explanation I have given for the previous example. Okay, next what? Next is that what is my trans resistance and trans Current gain is simply what 1, because IO is equals to II, and voltage gain is simply R, right? VO by II is equals to R. So that will be the conductance and resistance. I will compute that later on. Okay, I will compute that later on. Just initial final conditions, nothing, right? There is nothing. Like current source is connected across a resistor, so nothing to like say here. So you can do this very simply. So like initially my, like here no inductance is present, so I don't care what is my previous value, what is my current value, it doesn't matter. So my IO of 0 plus will be simply 1 amperes, right? 0 plus will be simply 1 amperes, and it will change, and my VO of 0 plus will be what? Or I can say here my IO of t, right? It will always remain at this 1, or I can write this as U of t, and my VO of t will always remain at what? R into E of t, I into R, right? So this is my V of t and I of t, and this is always the circuit. This is always the circuit. Circuit remains same because this is just a resistor. So plots, nothing to glorify. This will be simply current, okay, of 1 amperes, and this will be voltage of R volts. Voltage of R volts, okay. So pole zeros, again the same thing only, because this doesn't have any pole zeros. Basically there is only R, right? So here my VO by II will be simply R, okay, nothing. And my, like this Bode plot will be simply constant 20 log of R. Log of R. Bode phase plot will be simply 0. Okay, and what about the next thing? So next thing is about the current gain. Current gain is what? IO of S divided by II of S, which is equals to what? Which is simply equals to 1, because IO is equals to II. So again this will be like, this will be 0 dBs, okay, and this will be again 0 degree phase, because no phase shift will happen. This is just a constant number. So next I have another circuit. This circuit, right? This circuit is again same. This circuit is again same. If I copy everything from the this case, right, from the previous, like previous to previous case, that will remain same. So I'll just copy and paste that and just explain in a second. So here this portion, right, will be redundant for computation of voltage and current, right, for this inductor. This will be redundant. So everything will be same here, right? I just have a current source in series with the inductor. So whatever I have told for the previous to previous example, that will still be valid here, because I'm just analyzing the same thing. I will not explain the same thing here again. Okay, this voltage will be impulse because current is changing instantaneously across the inductor. Initial current was 0, then final current become 1 amperes. That's why at t equals 0 plus. Then translations simply S into L, right? And it will be like Bode plot, gain plot will be like this, Bode phase plot will be like this, plus 90. Then current gain is simply 1, because IO is equals to II. Then this will be only like Bode gain plot will be just 0 dB, and Bode phase plot will also be 0 dB. So this will be the solution of this question. Now let's go to the next question. So this is the next circuit. Again, this is a bit simpler circuit only. Just the difference will be here I have R and L. Again, right, this element will be redundant because the current through this is already fixed. That is II. That is fixed, right? So again, this element will be redundant, right? This element will be redundant. Okay, so if this element is redundant, so how can I draw the circuit? I can draw the circuit like this, right? I can remove the R just for computing the VO and IO. Remember, I'm just computing VO and IO. For that, this element is redundant. Else, this parameter will change few things, but not this VO and IO. It won't affect this VO and IO. Okay, so what will happen? The same thing, right? Initial flux was 0. Initial flux was 0. Hence, my Li 0 minus is 0 amperes. Okay, is 0. Hence, I will 0 plus, should it be 0? No, right? This is fixed because I will apply a unit step across it. So obviously the current will become at t equals to 0. T equals to 0 plus. What will happen? T equals 0 plus, this whole current of 1 amperes will flow through the inductor, right? Okay, will flow through the inductor. So obviously impulse voltage is getting applied at t equals to 0, that is delta of t. Then at infinity, what is happening? Obviously this is settling instantly because the current isn't changing after that. So I will just try to keep everything at the top. Okay, I can't keep everything at the top, unfortunately. I'm in myself at the bottom, right? Myself at the bottom. Okay, so if I copy this will be short circuit, right? This will be short circuit. So there is no problem with being short circuit because rate of change of current will be 0 and the current will be same only, that is 1 amperes. Okay, current will be same, that is 1 ampere. So my VL of infinity will be 0 volts, but what is my VO? VO is equals to this, like in this case, VO of 0 is what? L delta t plus R, and anyways delta is of infinite magnitude, so it will be only L delta of t. And in case of this side, infinity, this will be 0 voltage, this will give 0 voltage, this will give what? R drop, right? This will give R drop because the current IO of infinity is simply 1 amperes. So the response will be simply like this. It will follow the input, that is input current. Then this, I will get an impulse at t equals 0. Then the response will just follow the resistor drop, right? It will be R. Okay, it will be R. So this will be the voltage and current drops. Like pose and 0, same thing, right? Just difference will be there will be a R added with the SL right now. So it will be R plus SL. How will the body gain plot look for the trans resistance function? So here, right, what will happen is basically I have a non-zero DC gain. DC gain is R this time. So I will have a non-zero DC gain. So this value will be 20 log of R. Then next, if I keep on increasing the S, I'm getting a 0 at S equals to what? Like this is my transfer function, right? My transfer function is H of S equals to R plus SL. Hence my 0 is where? 0 is at 0 is at R by L. I mean this omega z is at R by L. So omega z is at R by L. So this will increase, but and this will provide a slope of 20 dB. 20 dB per decade. This will be omega z. Okay, so obviously here, right, I don't have any slope because it is just starting, so the slope will be 0 dB per decade. And what about the phase plot? So the phase plot will also be simple. Phase plot will be what? Simply if I increase my phase shift, right? If I increase my phase shift, so initially my 0 is like, if at S equals to 0, angle is 0, so it will start off with 0 angle. Then 10 times before the 0, the effect of 0 will come. Okay, it will provide me a slope of plus 45 degree per decade, and it will go on till 10 times more than the 0. Okay, then it will settle here, and at infinity, S equals to infinity, the angle will be what? 90. Why? Because overall I have a 1 0, so obviously there will be overall angle will be 90. So this will be 90 degrees. Okay, this will be 0 degrees. Now this is omega z. So omega z by 10. So yeah, this slope is how much? This slope is plus 45 degree per decade due to the 0. Okay, so yeah, this is one. Like the current gain is 1, that won't change anything. So this Bode gain plot, this will be only 0 dBs, this Bode phase plot will be only 0 degrees. So everything will be same here. Okay, now let's come to this question. This question at first seems intimidating, but really it isn't, right? Again, what is happening? Again, this element is redundant, because again, if I apply the same thing, that if I apply the current division, right, this I1 and this I2. Okay, and here I have, what is this? This current is IO and this current is II. So obviously whatever comes into the node should come out of this particular node, right? If it's a circuit that is connected between two other networks. So obviously I can directly conclude that my IO equals to II. So this element again, right? This element again is redundant. This element again is redundant. This element again is redundant. So this is the case here. So again, like, what is this circuit? Actually, this circuit is simply a parallel RL circuit. This circuit is simply parallel RL circuit. Just the names have changed here. Okay, and I have already analyzed this circuit. Right? I have already analyzed this circuit. So everything will remain same here. Whatever the analysis for that part, right? I think this was for the first circuit that I solved. Everything will be same. Time constant will be this time L2 by R2. Okay, and everything else will be remain same, right? This will be VL2. Everything will just change to 2 this time. Nothing else will change. This will be R2. This will be L2. Okay, and this is R2 again. It will get shorted. So here, yeah, this will be R2, and yeah, this is tau only. This will be R2. Okay, else everything else will remain same. And like impulse response also will be same. Just that this drop will be equals to delta T into R2. Because the area will be R2 this time. This again R2. So like I am not explaining because this has been explained in the first part itself, right? And this will be R2 L2, and yeah, this is R2 L2. Yeah, everything is like this only. And here as well, like after that there will be a drop of R2 by L2 square, and this current will be R2 by L2, and this is R2 L2. Yeah, this is at T equals to infinity. Right. Previously, I think I forgot to wrote this equal to infinity, and this values will just change, but graph shape, right? Graph shape will remain same. Okay, graph shape will remain same. This is the case. I made a mistake. I think here this should have been R2 square by L2. I think there I made a mistake. Yeah, it should have been R2 square by L2. So yeah, I'll just rectify it in my PDFs there. So poles and zeros are same, only what the notations will change, nothing else, right? Nothing else will change, notations will change. So I'll just do this and like change this, nothing else will change, and I will solve the final circuit. So let's finally solve this last circuit. So this last circuit also may seem intimidating at first, but again this will be simple, but not as simple as the previous circuits, but this will be simpler here. What will happen here? So here, right, if I observe, like if I name the terminals 1, 2, 3, 4, and if you have already seen lectures from me, you will know we can convert this circuit. What we can convert this? We can convert this in the form of a bridge circuit. So here, right, if I name the terminals as 1, 2, 3, 4, so between 1 and 2 I have R1, and between 1 and 4 I have L1. So between 1 and 2 I have R1, and 1 and 4 I have L1, and 1 has other point connected to the current source. Then between 3 and 2 I have L2, and between 3 and 4 I have R2. So 3 and 2 I have L2, and 3 and 4 I have R2, right? And VO is obviously between 2 and 4, and II is between 1 and 3. So now this seems more simpler because obviously this is open-ended, right? There is no current flowing, so these two circuits are in parallel with each other. So how will the current get divided? Current, right? I can apply simple current division, or if you want to do this with intuition, you can do this with intuition as well. But this will be a first order circuit. Why this will be a first order circuit? Here, right, the thing is, obviously the output and input are not connected that simply, so I cannot use those intuitive methods to compute everything, right? But one thing obviously I can do is finding the order. So if I give this some initial current, right, if I give this some initial current of, let's say, IL2, if I give this some initial current of IL2, then this, right, this current is fixed. This current is fixed, that is II minus IL2. So obviously, right, if this current is fixed, obviously overall there is only one independent energy storing element in this whole network. So the order will be 1 only. Order will be 1. If you want to like say how, sir, I will prove it to you. Okay, now if the order is 1, definitely there will be a time constant because response will be exponential. Response will be exponential. Okay, response will be exponential, right? So what will happen is that what is the time constant? Time constant is again, time constant is L equivalent upon R equivalent. Okay, time constant is L equivalent upon R equivalent. So what is L equivalent? L equivalent is basically what? In this case, right? If I observe, how do I find L equivalent? I remove the source, right? I make the effect of the source 0. Okay, what has happened here? Okay, this is some weird thing is happening. Okay, unfortunately I cannot do anything right now. This is something weird that has been happened here. This is not moving again also. Okay, this will get, I think this will get automatically fixed. So if I draw the circuit, right, if I just draw the circuit without the source, okay, just reduce the size again. If I remove the source with this, so what will happen? So here, right, here, what can I say is that if I have a current across this IL2, right, then the same current will flow through this. The same current IL2 will flow through this, right, this whole circuit, because current through here is 0. This is open-ended, right? This is open-ended. Current through here is also 0. So obviously L1 and L2 are in series. R1 and R2 are also in series. So my L equivalent will be L1 plus L2. Okay. My R equivalent will be R1 plus R2. Okay, L equivalent will be L1 plus L2, R equivalent will be R1 plus R2. So this, in this case, I will assume for simplicity, I will assume L1 equals to L2, so this will be 2L, and R1 equals to R2, so this will be 2R. So my tau, right, tau will be L by R. Okay, now I told you, right, I will prove it to you. So here, right, if I directly write the what output voltage equation, first I will write the currents. First I will write the currents in frequency domain. So I will use Laplace, obviously to prove, obviously I have to use Laplace. So my IL1 of S will be simply what? It will be simply a current division CDR. So it is the opposite impedance, that is R1 plus, did I write L1? Okay, yeah, R1 plus SL2 divided by the total impedance, that is R1 plus R2 plus S into L1 plus L2. Basically I'm adding this, I'm adding these two impedances, right, these two impedances. Okay, next. So this is the IL1 into, obviously I have I of S. This is IL1, right? Now what is IL2? If I want to write IL2 of S, so IL2 of S is simply, again, the opposite impedance. This is, I'm computing the current across this inductor. I will write the opposite impedance and divided by total impedance. So opposite impedance is S L1 plus R2. I'm sorry for this. I just need to have a drink of water. Yeah, just needed a bit of water. So this will be R1 plus R2 plus S L1 plus L2. Okay, into II, obviously II of S. Now what is my required thing? My required thing is this, right? My VO. Okay, VO is what? VO is simply IL2 into SL2, right? This, impedance. So VO is basically V2, and if I assume this as ground, right? If I assume this as ground, VO is basically V2 minus V4. So what is V2? V2 is SL2 into IL2. What is IL2? IL2 I have just computed it. Just computed. So whatever this is, I will just okay, I will write this, because the denominator will be common. Okay, denominator will be common. Denominator I will write at the end, and subtracted by V4. What is V4? V4 is IL1 into R2, right? IL1 into R2. So what is IL1? IL1 is this. Okay, the numerator is this. So I will copy this. Just hold on. into R2 obviously. R2 will be present here, okay, and divided by common denominator, because both of them have same denominator, that is R1 plus R2 plus S into L1 plus L2. So like obviously I can say, right, I can say this is a first order circuit. Like here the number of poles is only is one single point, okay. Like here one important point to note here is this will be S square L1 L2 and this will be S R2. So if my L1 was equals to L2, can I deduce something? So that you have to check if my L1 is equal to L2. So like this you can write the transfer function, and from here I can intuitively say this is the pole, and from there you can draw the Bode plot and Bode phase plot. But the important point, like I will not draw the Bode plot and Bode phase plot for this. This will be a non-minimum phase system, and I have previously drawn Bode phase plot for these type of circuits, right? For a non-minimum phase system, you can watch my previous marathon, okay? So I will not waste my time here. So like I proven to you that why is this a first order circuit. Now let's solve basically the unit step solves, because unit impulse response will also be similar only. So here, right, initially what will happen if I apply a unit step across it? If I apply a unit step across it, obviously the currents will get divided. How will the currents will get divided? So if I apply unit step, then at t equals 0 plus, both will provide infinite impedance, and as these two are in series, right, what will happen? Like inductors will dominate than R1, right? This inductors will dominate than resistors. So here I can remove the resistors, because I can ignore the resistors, because inductance will provide huge amount of impedance. So resistors can be ignored for now, okay? Resistors can be ignored for now. So I can directly draw this, and I can directly draw this, okay. So the current division will be according to L2 and L1. So how will the current division be? So I can write this is a simply 1 amp current source at t equals to 0, okay. So here, right, what will happen? Current, right, let me compute the, I will write the currents here. This is my I L1, my IL2, okay. IL1 is equals to 0. IL1 is equals to, like it will be again L2 SL2 by SL S into L1 plus L2. So it will be on the opposite impedance divided by L1 plus L2, and IL2 of 0 will be simply L1 divided by L1 plus L2. Now what is my VO of 0? My VO of 0 will be simply voltage across this inductor, right? Voltage across this inductor. What is the voltage across this inductor? The voltage across this inductor is actually impulse. What is the impulse? Area of the impulse will be this, right? Area of the impulse will be this, because the current suddenly changed from 0 to infinity, because initially the inductor has no flux. This I have been repeating throughout the whole marathon, so I'm sorry for anyone who is getting bored from this. I'm really sorry, okay. So this is L2 into I, like this is L into I. So an initial current is 0 from this 0 minus, right? So obviously initial current I L1 equals to I L1 0 minus equals to I L2 0 minus equals to 0 amperes. Okay, so what can I say? What can I say about this? VO of 0 will be a impulse of area L1 by L1 plus L2, because this will be 0, right? Because the drop across this will be like not will be exactly equals to 0, but like this will be some finite value, but as there is impulse at t equals 0, that will be eliminated. That will be eliminated, okay, because infinity minus anything is infinity, infinity plus anything is infinity, right? So what is happening at t equals to 0 plus? What is happening at t equals 0 plus? So t equals 0 plus, I need to draw the circuit. So this inductor, now I cannot ignore the resistors, because this inductor has some current, right? So what is that value of the current? Value of the current this inductor has is IL2, right? IL2, this is the IL2. I will not write the values because those are big numbers. This IL2 and this, right, this is IL1. Okay, this is R1, this is R2. Okay, this is R1, this is R2. So now at t equals 0 plus, what will be the voltage? So again I can write the same equation, right? What equation can I write? That 1 equals to, like 1 ampere of current equals to IL1 plus IL2. That will always be true no matter what. Again I can apply the, like, differentiate on both sides. So my dIL1 divided by dt will be equals to minus dIL2 divided by dt, right? So now the thing will be that this will be negative of each other, but I cannot say about the voltages. Why? Because L1 and L2 are basically different, right? They are not same. If they are same, if L1 equals to L2, then this current will be 1 by 2 and this will settle instantly. This will settle instantly, or will it? Yeah, this will settle instantly, right? Okay, no, this will not settle instantly. This will depend on the values of R. So if I assume for now that my L1 is equals to L2 is equals to L, then if I multiply L on both sides, I can directly say that my VL1 will be equals to VL2. Okay, if I say this, so if VL1 is equals to VL2, not equals to minus VL2, right? So now if I apply simple KVL, so like, what is this IL2 current then? If both of them are equal, what is this current? This current will become half, because L1 is equals to L2, and this current will also become half, 1 by 2 amperes. Okay, so what will be the drop basically across this? So this is, like, this was my VL2 and this was my VL1, right? If I apply a KVL, this will be minus VL2 plus minus R by 2, then plus VL1. Okay, and this is, am I doing this correctly? Yeah, I'm doing this correctly. And this is 1 by 2, like, this is plus R by 2, right? Okay, this is R1 and this is R2, right? This is R1 and R2. This was R1 and this is R2. Okay, fine. Equals to 0. So I have said you, right? So my VL1 is equals to minus VL2. So if I replace this with minus VL2, this will be minus 2 VL2, and on that side this will be plus and this will be minus. So I will take the minus sign common. R2 minus R1 divided by 2. Okay, R2 minus R1 divided by 2. So my VL2 is equals to R2 minus R1 divided by 4, right? This is the value. Now it will all depend which one is greater. If R2 is greater, obviously this will be some positive value. If R1 is greater, this will be some negative value. I am not sure which one will be, like, what will be what. Okay, so at steady state, what will happen? At steady state, right? At steady state, current won't change, so dIL by dt will remain 0. So if dIL by dt remains 0, inductors will get short circuit, right? There will be no voltage drop. So not voltage drop, there will be no change in voltage, so inductors will get short circuit, and the currents will be constant. What will the currents? I will just say the currents will be IL1 and IL2. Okay, this is across this. This is IL1 and IL2. And what is the value of IL1 and IL2? This is IL1 of infinity and IL2 of infinity, right? So here, right, what will be my IL1 of infinity? That is short circuit, right? That is short circuit. Voltage drop is 0. So the currents, like they will both provide very low impedance. So currents will be dependent on this R1 and R2. So IL1 of infinity will be simply R1 divided by R1 plus R2, and IL2 of infinity will be simply R2 divided by R1 plus R2. Okay, so what is VO? Like what is VO here? So what is my VO here? So VO, right? VO is simply this VL2, because this is grounded, right? This is grounded. VL2 minus this current into R2, right? Basically R2 by 2. R2 by 2. So what is VL2? VL2 is R2 minus R1 divided by 4, or I can write like this: 4 minus R2 by 2. Okay, so my VO will be some negative value. Actually, this will be minus of R1 plus R2 divided by 4. Okay, this will be some negative value. Then at infinity, what is happening? In infinity, VO of infinity will be what? This is again grounded. This will be equals to, if I just write this down, okay, I'm doing everything correctly over here, right? So yeah, just thinking like, is everything correct here? Yeah, this will be the current, this will be the voltage. If L1 is equals to L2, VL2 is, yeah, VL2 have applied the KVL, half of current is flowing, fine. Yeah, everything is correct here. Okay, R2 minus R1, yeah. So, for right current, this is resistance into the current, yeah, into half, yeah, that is good. Here, what is infinity? Infinity, right? This point is 0 volts, right? This is grounded and this is 0. So 0 minus IL1 infinity into R2. What is IL1 infinity? IL1 infinity is R1. So this will be R2 R1 divided by R1 plus R2. Okay, R1 plus R2. So this will be the result of infinite voltage. Okay, this will be the result of infinite voltage, and of course there is a initially there is a impulse present here. Initially there is a impulse present here of the output voltage. So how will the output voltage look like? Output voltage, right? Output voltage, these are the currents. So what are the inductor currents? So initially, right, inductor current, both of them, like this will be L2 into L1 plus L2, this will be L1 into L1 plus L2. So I don't know if both of them are equal. If both of them are equal, both of them will instantly go to half. Both of them will instantly go to half. Then it depends, right? It depends where they go. It depends on this value. Where did it go? This value, right? R1 divided by R2 plus R2 and this. So I don't know whether this is more or whether this is less. So I will just assume. What will I assume? I will assume that R2 by R1 is greater than 1. So if R2 by R1 is greater than 1, so if I divide by here R2 on both sides, if I divide by R1 on both sides, right? If I divide by R1 on both sides, what will this become? This will become 1 divided by 1 plus R2 by R1, and this, if I divide R2 on both sides, this will become, or yeah, I should divide R2 on both sides, this will become R1 by R2 plus 1. So here, right, I have said R2 by R1 is greater than 0. So this point, this quantity is greater than 0. So overall this will be, sorry, this quantity is greater than 1. So overall this will be greater than 1. Like very, very large than 1. Okay. And if I say, if this quantity, right, R1 by R2 will be less than 1. Okay, R1 by R2 will be less than 1. So it will be very small and this will be very large. So obviously IL1, I can conclude from here that IL1 of infinity will be less than IL2 of infinity. Okay, so IL2 will rise, and will settle to this IL2 infinity. So this is the initial value, that is 1 by 2. I have assumed that L1 is equals to L2. Then I have assumed that they are settling here. Okay, this value is what? This value is IL of 1 of infinity. So this will be the current waveforms of the inductor, right? So now what will be the voltage waveforms? So like this, I can plot the resistor. So resistor, right? VR1 is what VR1 is simply the current across this L2 times this, like R1 times this. So first of all, I will write this case, that this is the case, right? This is the case that I am assume. So this is just an assumption. The plots will just reverse. Okay, and if all of them are equal, everything will be same, half. So this is IL2 into R1, right? So for VR1, right, so I have to multiply IL2. So this will be the case. So the plot will look something like this. Okay, here just everything will be same, just R1 will get multiplied. R1 into IL2 infinity, and this is R by 2, right? R1 by 2, because half amperes of current was flowing. Okay, next what happens? Next, this VR2, right? VR2 will just be the opposite. VR2 will just be the opposite. This will suddenly go to 1 by 2 and this will decay. Okay, this will decay. So this will be what? This will be R2 by 2, and this will decay to what value? Decay to R2 into IL 1 of infinity. IL 1 of infinity, right? R2 into IL 1 of infinity. So these will be the VR2. And what is the inductance? So inductance, right? Obviously, both of them, an impulse will come, that is L by 2. Okay, because they are both getting charged to 1 by 2 of current, L by 2. Next, what is happening next, right? So my VL1 voltage also, I don't know what it will be. So I have assumed that this, right, this is decaying, right? This is decaying. So what is the slope of this? Slope of this is negative. So VL1, right, it will be something negative. VL1 will be negative as it is decaying, and it will go to 0. And this VL2, right, it will be something positive. And it will decay down to 0. Okay, so what are these values? These values I have already computed here, right? These values I have already computed, that is this. Okay, this value, not this. This is the VO, this is VL2. So R2 minus R1 by 4 is this. So this is VL2, right? So this will be R2 minus divided by 4, and this will be R1 minus R2 divided by 4. Okay, so this will be the negative of this. So this will be the currents, and like this is the 4 tau, everything is 4 tau, right? Everything is 4 tau. Here, settle at 4 tau. This is also settling at 4 tau. So all these are same. Okay, so like you can obviously easily plot the output voltage as well. Like what is the output voltage? So initially across the output, right, I've also wrote the output voltage as well. Initially I'm getting an impulse of L1 divided by L1 plus L2, that is L by 2 delta t, right? So impulse will come. Okay, so impulse will come L by 2. Okay, then at t equals to 0 plus, what is the VO? VO of 0 plus at t equals to 0 is minus R1 plus R2 divided by 4. So this will be minus of R1 by R2 divided by 4. Then obviously it goes to, does it go to 0? It doesn't go to 0, right? It doesn't go to 0. It goes to this minus R2 into R1 divided by R1 plus R2. So this will be something negative only. So here this will be something like this. Okay, so it will be something like this. So what is the homework for you? Homework is try to plot the impulse response, right? Like impulse response will also be simple. Okay, this is the first order circuit only, and I have already done enough examples so that you are able to understand how to plot the impulse response as well. Okay. Unfortunately, this has been wired, so I cannot do anything. Okay. So this is my VO, and this value is what? This value is minus of R1 plus R2 divided by 4. And this value is minus of R1 R2 divided by R1 plus R2. Okay. So these are the plots, and this is the end of this marathon. Okay, so thank you if you watched till then, and let me know in the comments below if you did watch till then. Okay, and I did all this in a very hurry, within just 2 days, because a few students were asking can you do a marathon on RL, because enough content is not there, and that's why I had taken the poll and it has seen enough interest. That's why I had to do this. So I had to put up a all-nighter to ready prepare all the content and record all this, right? So at least you can give a like for all the efforts. Thank you for watching, and if you want more content like this, do subscribe, do share with your friends, and you can repost my LinkedIn post. You can follow me at LinkedIn. There I regularly post notes and all. So yeah, thank you for watching, and I will see you in the next video.